What's up YouTube, this is Dennis Panuta for tutorials.eu. In this video you are going to learn the basics of Linux and the terminal. And it's super helpful for any developer, but also in general. So 3 hours of amazing content with my friend Jannis Seemann, who has over 250,000 students on the German market already with a 4.6 star rating average. He's an amazing instructor and I always looked up to him for his amazing quality and reviews that he's gotten. So 3 hours of knowledge about Linux basics, understanding Linux in general, the different distributions, as well as the fundamentals of the terminal await you. So now I'm handing over to my friend Jannis.
A big thanks to Dennis for this great introduction. So in this video here on YouTube, you will learn how to set up a Linux system in a virtual machine. This will allow you to use Linux, and if you break something, you can just reset this virtual machine. It's like a separated environment from your main operating system. This is somewhat optional. If you already have a Linux system, you can also just use that. Then we will have a look at how you can use the terminal, and we will first have a look at how you can manage files in Bash. After that, we will also have a look at how you can take a command and redirect its input or the output of that program into a file. This will allow you to use commands in the terminal and then store the result of those programs for later use. After that, we will have a look at how you can combine multiple programs in the terminal together through pipes, and this will allow you to even execute complex workflows with the terminal and to manage all of this. This is everything that you need to get a great start into using the terminal, and this is what I will be providing you in this video here. However, if you want to learn more, this is just a part of a 70+ hour long course about Linux, and in this 70-hour course, you will also learn more about the Bash command line and more advanced use cases, for example, how to configure the terminal, how to work with colors there, how to run more complex tasks or commands there. But you will also learn a lot about Linux, about how the boot procedure works, how you can keep your Linux system up to date, how the networking stack works, or even how advanced security concepts such as SE Linux work. Also in this course, you will also learn about Bash scripting. This will allow you to take the Bash commands that we will be looking at in this video here and turn them into a Bash script, and then there are advanced features that are more relevant for Bash scripting, and we will also dedicate several hours to all of that. In addition, in the 70+ hour long course, you will also get additional quizzes, exercises, and a question and answer area if you have any questions. So this is a more complete package if you really want to become a Linux expert with just one online course. If you are interested in this course, be sure to scroll down a little bit and click on the link, and then you can sign up for this course. So, with all of that being said, let's now get started with this course. Hello and welcome here to my course about Linux and the command line. I want to start this by telling you a little bit about me so that you can relate where I'm coming from and why I'm developing this course. So my name is Jannis Seemann. I'm German, but I grew up in Budapest in Hungary, but then moved back to Germany for my degree in computer science. I did 2 internships while studying at Google, but nowadays I'm a freelance web developer just because I love traveling so much. I love that I can control my job completely myself, and for that I'm also the server admin of a few servers. Also, I've developed quite a few courses here for Udemy. I'm one of the most popular instructors on the German-speaking market on Udemy with over 250,000 students there. This background is extremely important for this course because this lays the foundation for this course. You benefit from my work experience, and you also benefit from my extensive teaching experience from the German market, but don't worry about it, this course is completely in English. So what will you be learning here in this course? Well, all of those topics and actually way more. I was thinking of including all the topics, but then I realized if I want the font to be readable, I can't even add all the topics that you will be learning here in this course. So this course is extremely comprehensive. Instead of going through all of them, I want to present you the structure here of that course to give you a more general overview. The first part is the introduction. We are already in that one. In that, we are having a look at the course, and we will also be preparing and setting up your system so that everything is ready, that we can start with the command line and how everything works. After that, we are ready to explore Bash, and during this part it will mostly be about the command line and how we can just use the command line to familiarize ourselves with the terminal and how everything works there. After that, we are ready for part 3, that's the Linux part. In that part, the goal is to understand core Linux concepts. So we will talk about how file permissions work, we will talk about how package management works on detail, we will have a look at how even advanced topics work, such as networking or SE Linux. So this part really prepares you then to use Linux. After that, we will have a look at advanced Bash, and during this part, we will have a look at how you can create Bash scripts that will allow you to automate your workflows through Bash scripts. The goal here is that after part 1, you will have a running system that you can just use to practice Linux. After part 2, you will be a master of the command line and you know what you are doing there. After part 3, you know how Linux works and you can interact with Linux from the command line and you know how everything works there, how you can debug problems. And after part 4, you will be able to automate your workflow with Bash scripts and you know all the little details from the command line for even more advanced use cases here. This structure is unique to this course. A lot of other courses focus either on the command line or Bash or on Linux. This course is more comprehensive. This is a step-by-step guide that will bring you to an expert level, not just on the command line, but also when it comes to interacting with the Linux operating system. All in all, this course is over 65 hours of content in length. It's the most comprehensive course I've ever developed. It also took the most amount of work ever, over 8 months of development, and on top of that I had support from 2 amazing freelancers for additional quizzes, proof watching, exercises, and so on. I'm saying this because I really want to thank you for buying and watching this course. This allows me to create such a comprehensive guide, and this really means a lot to me. With all of that in mind, let's now continue here in this chapter and let's have a look at why you should really go through this course. Why should you learn Linux? I want to continue this chapter by asking you a few questions. You don't need to tell me your answers. It's just important that you try to answer those questions for yourself. And the big question here is, what is your goal? Why do you want to learn Linux? Is your goal that you want to start working with? Is your goal that you want to work with servers, or do you want to develop and deploy applications there? Are you preparing for a professional certification? Do you want to boost your career? Do you want to learn Linux for personal use, for personal projects? Or are you maybe even using Linux as your primary operating system, or do you want to? For all of those answers, and probably even way more answers here, this course is the right course for you. This course is unique because you do not just learn the command line, you do not just learn Linux, you do not just learn Bash scripting, but you learn all at once and everything builds on top of each other. My advice here to you would be try to visualize your goal because it's a marathon, it's not a sprint. The next question is, what's the best approach here to this course? And one thing that I can recommend you is to just follow along with the course structure, because we start here with the foundational concepts and then we will gradually move towards more complex topics. So if you just follow along, you will become a Linux expert and everything will be clear, everything builds on top of other stuff. Also, I've tried to add as many quizzes and exercises here to this course as I could. So try to utilize them to test your knowledge and also to exercise what you've just learned. You can also try to skip chapters if you feel like they are really not relevant for you. Just be aware, maybe some chapters later in the course might depend on that, though there are also topics or chapters that are marked as optionals. Those you can definitely skip without any issues. Also, practice makes the master. So I would recommend you to try to set a few hours per week aside just for studying Linux, and then just see how far you get in those few hours. Also, it's really important that you try to run the commands that we will have a look at here on your own system, and that you experiment and challenge yourself, so that you don't just copy what I do in the lectures, but that you also see, oh, can I also do this here? And then you experiment and challenge yourself. Remember, again, it's a marathon, it's not a sprint. Also, seek support when necessary. So if you have any questions, if you are stuck, feel free to research the questions online first. But if you don't find any answers, this is an online course. I can guide you here. Reach out in the question and answers area to other fellow students and also to us. We'll try our best to get back to you within a few working days. The good thing here is this is a course that's structured for you to really learn and understand Linux, not just to learn, but really to understand Linux on a very deep level. So you will first become fluent on the command line, then you will understand everything about Linux, and then you will become a Bash expert, and you will also be able to write advanced Bash scripts and utilize them. So this course is structured to make you succeed. You just need to follow through and follow along. This course then will get you to your goal of really understanding Linux. The next step here in this chapter is that we need to install a Linux on your computer. The goal is that we have an isolated environment in which you can just play around and destroy something, and it doesn't affect the rest of the system. And for that, we will need to install quite a few tools there. But before we can do even that, we need to have a quick look at what do we want to install here? What is Linux? How does it all work? And this is what we will have a look at in the next lecture. A quick interruption. If you want to learn more, this video here, it's just an excerpt of a 70+ hour long course about Linux. In this course, you will learn way more about Bash command line. For example, we will configure your terminal, or we will have a look at how colors work and everything like that. But you will also learn everything you need to know about Linux and how you can write Bash scripts, for example, a backup script. This course is super extensive because I decided to add so many different topics into this, so this is really the complete guide if you want to master Linux. In this course, you will also get quizzes, exercises, and a question and answer area. This is something that I cannot provide to you in this YouTube video here, unfortunately. So if you're interested, be sure to scroll down. I have provided a link for you there. However, let's now continue here with this video, and let's now get you started with using the terminal. Before you install anything on your computer, the first question is, what is Linux? And what's the distinction there? And Linux is an operating system that's extremely popular, especially for servers, in data centers for cloud computers, on microcomputers, for cybersecurity, but also for Internet of Things. Also, in case you have an Android smartphone, even that is running on Linux. Fun fact, by the way, even if you're an iPhone user, you're using something called Unix as the foundation of your iPhone operating system. But what's the distinction there? What's Linux? What is Unix? And how does it all relate together? And Linux is the kernel of a family of open source Unix-like operating systems. This sounds a little bit technical, but let's just go through. Let's start with operating systems. That's a system software that manages computer hardware and provides various services for computer programs. So, for example, Windows could be considered an operating system, and it provides a lot of services. It provides network communication there, it provides a new user interface. So this would all be part of the operating system. Then we have the term Unix here, that Unix is a powerful multitasking, multi-user operating system that serves as the basis for many modern operating systems. Why it's just Unix-like here, we will have a look at this in the next slide actually. Let's go through here. Multitasking means that we can run multiple applications at the same time, and multi-user means that we can have different permission levels active at the same time. So just as an example, if you double click on an executable file on Windows and then Windows asks you, hey, are you really sure you need to grant additional privileges to this application? Even that would already be considered multi-user here. So Unix is just an operating system here, and kernel means that the kernel is the core part of an operating system. So it's responsible for managing the hardware, including the processor, the memory, and all the other devices. So what is Linux? Linux is the kernel, what's managing the hardware of a family of open source Unix-like operating systems. So we know it's kind of like the core part of that operating system, though the last part here with Unix-like is not entirely clear yet. And for this, we can have a look at the GNU project. GNU stands for GNU is not Unix, and the goal here is to create a free and open source operating system. It was initiated in 1983, and most of that software is released under the GNU General Public License, or GPL, and this means it's like a very strong open source license, so that if I would give you GNU software, I would also be obliged to give you the source code, and you could modify the source code. So there are a lot of things like this in this license. The Linux kernel is also released under this license, and GNU provides many of the additional tools and utilities that we want to use. Linux provides the kernel, GNU all the other utilities, and by combining that, we get a Unix-like operating system, because Unix used to be proprietary, so GNU/Linux, this formed together is pretty much a replacement for the Unix that we had before. So this is how GNU Linux works. However, nowadays, if we talk about Linux, we usually just mean GNU Linux, which means that we take the core of this GNU project and combine it with the Linux kernel. And usually nowadays, we might just call this Linux to simplify our language here. Nonetheless, technically speaking, it's GNU/Linux that we are using. Linux is just, technically speaking, just the kernel that we are using here. So now we know what Linux is, but then there are many different Linux distributions, and how they work. This is the topic of the next lecture. In this lecture, we want to have a look at Linux distributions and how they work. And this lecture is especially important because in this course, you will have the choice between two different Linux distributions, Ubuntu and CentOS Stream, and I will also show you how to make a good decision there. Nonetheless, you can also install both on your system. But let's have a look at what Linux distributions are. So Linux distributions are various operating systems that are built on top of GNU Linux, and they are then called Linux distributions or distros, or however we want to abbreviate it. So we got our GNU Linux core, meaning the Linux kernel and GNU around it. And then each distribution then adds additional specific software, and this then allows to cater to the needs of a specific user group. A lot of this additional specific software overlaps. So for example, specific web servers are available for a lot of different Linux distributions, but each of those Linux distributions might have some minor differences in how they approach things or how things are configured by default to cater to the needs of a specific user group. Most of those Linux distributions are free. Some of them are paid. So that means for some of them, you do need to pay money in order to get access to it. This seems to be allowed according to the open source license, as long as all paying users also get access to the source code. Nonetheless, most Linux distributions are completely free and we can just use them. In this course, we will be exploring two really popular Linux distributions. One will be Ubuntu. Ubuntu is part of another Linux distribution family called Debian, so it's part of that family, and it derives a lot of things from there. And as a member of this family, we will have a look at this, and we will be using Ubuntu because it's designed to be especially user-friendly. Then we will also have a look at CentOS Stream. This is part of the Red Hat family, and it's free to use, and it allows us to familiarize ourselves with the Red Hat family and especially Red Hat Enterprise Linux without paying or without needing to pay anything for that. So these are the two Linux distributions that I've picked here for this course. So I've checked all my examples that I show you, that they either work in both of those Linux distributions, and when it's not possible, I will make it clear that there's, for example, one chapter that only works on CentOS Stream. That would be the topic about SE Linux, because that's not properly integrated into Ubuntu. So there are some minor differences here, but for now, you can just choose one of those two, and then later we will have actually a dedicated chapter about Linux distributions, how the Debian family works, what the Red Hat family is, what other Linux distributions are there. So we will have a dedicated chapter to that. For now, we can leave it at that, because in this course, Ubuntu and CentOS are the two choices, and in general, those are two really good choices for starting to learn Linux. Now that you have those two choices, which Linux distribution should you choose? Should you choose Ubuntu or CentOS Stream? And the big question here, this would be my guide here for you that you can just follow. The question is, how do you plan to use Linux? If you're planning to use Linux for personal use, then you can just choose Ubuntu for now. If you're planning to use Linux for professional use, meaning for your job or for your startup or for any other project that's a little bit more serious, then the next question should be, what is the scale of that project and how serious is that project? And if it's just a local PC or a small server without any sensitive data, so if you do not need additional levels of security, additional layers of security added there, then you can just use Ubuntu here. And if it's a larger scale server, or the server will store sensitive information, maybe credit card information or something like that, then you might want to choose CentOS Stream. Also, those would be all the projects in which paying for a license fee to then eventually switch to Red Hat Enterprise Linux or something like that would not really be a breaking issue there. So if it's like a large project or a really serious project or a project with sensitive data, then I would recommend you to follow along with CentOS Stream, otherwise with Ubuntu. If you're still unsure and you're just like, hey, I just want to learn Linux, I want to get a feeling how everything works, so when in doubt, I would also just recommend you to use Ubuntu here. So this would be my guide to choose the right Linux distribution here for this course. Be aware you can just easily install the other Linux distribution on your system as well. So this is not a final decision, but I would recommend you to, at first at least, follow along with only one of those distributions, because this is enough for learning and understanding Linux for now. So now you know which Linux distribution you should choose to follow along here. And after a quick quiz, we will be having a look at how we can install a software on your system that allows you to run this Linux distribution in an isolated environment on your computer. A quick interruption. If you want to learn more, this video here, it's just an excerpt of a 70+ hour long course about Linux. In this course, you will learn way more about Bash command line. For example, we will configure your terminal, or we will have a look at how colors work and everything like that. But you will also learn everything you need to know about Linux and how you can write Bash scripts, for example, a backup script. This course is super extensive because I decided to add so many different topics into this, so this is really the complete guide if you want to master Linux. In this course, you will also get quizzes, exercises, and a question and answer area. This is something that I cannot provide to you in this YouTube video here, unfortunately. So if you're interested, be sure to scroll down. I have provided a link for you there. However, let's now continue here with this video, and let's now get you started with using the terminal. So how are we able to run Linux on our computer? Maybe you're already running Linux and you're watching this course on a Linux system. However, even then, this lecture here is relevant for you because you might want to do everything you learn here in the course within an isolated Linux environment. And the goal here is to create an isolated Linux environment. So even if you're already running Linux, this lecture is important for you. So one option would be that we would install Linux on our computer as a main operating system. We could then reboot and choose to boot into Linux. A lot of Linux distributions offer this kind of install. This would then be called a dual boot. That means we can just reboot into Linux, and then if we want to go back to Windows, we could just reboot and choose Windows at the beginning. This could work, but for learning Linux, I cannot recommend it. The best approach is here to run Linux virtualized. No matter whether you're running on a Mac, Linux, or Windows, it's best to run the Linux that we want to learn Linux with virtualized. And the idea here is that we have our main operating system. Here in this case, in this graphic, it's a Windows. And within that, we just install an application that allows us to have a virtual computer that's then running on our normal computer. So everything will be virtualized. We will have a separate virtual computer running on our computer. Don't worry, it's no additional hardware you need to purchase. It's just some additional free software that you need to install on your computer. And then we got a virtual computer, and on that one, we will then run our Linux that we want to use to practice Linux. The advantages here are enormous. If, for example, we destroy our Linux system, there's nothing to worry about. It's not our main computer, it's just a virtual computer. We can just reinstall it. Or we can just copy, or we can just create a backup of our virtual computer, destroy something, and then go back to the backup, and we have a working system again. And it also allows us to not just have one virtual computer running on our computer, but multiple. Maybe one for Ubuntu, maybe one for CentOS, maybe another one for another Linux distribution that you want to try out as well. So the advantages here are enormous. How can we use, or how can we create such a virtual computer? For this, I need to give a little heads up for all the Mac users, unfortunately. If you're using Mac, it depends a little bit about the processor. So if you have an Intel processor, you can use a tool called VirtualBox, which is what we will be using here in this lecture. You can then keep following this guide. If you have an Apple processor, be aware that VirtualBox as of now doesn't work properly on your system. Thus, I've provided you with a specialized guide to follow. We will be using a different software then called UTM. To find out which kind of processor you have, you can go here on the Apple logo, then about this Mac, and then like a menu shows up or a window. And if the chip here is something with Apple, M1, M2, M3, whatever, then you have an Apple processor. But if here it says something about Intel, then you have an Intel processor. So if you have Mac and Intel, you can follow along. If you have Mac and an Apple processor, then you need to watch the corresponding guide for UTM. I have labeled the lectures accordingly. So what is VirtualBox? VirtualBox is a virtualization software that allows you to create and run a virtual machine on your computer. It's developed by Oracle Corporation, and it's free and open source software again. The installation goes the following. We need to go to virtualbox.org and then go to the downloads there to then install this on our system. VirtualBox is available for Windows, Mac, and Linux. So you can use this on all operating systems. I will only show the install procedure on a Windows machine. On Mac and Linux, you can just follow the guide from virtualbox.org. So here we are at the website of virtualbox.org. To download it, I can just click on Downloads here. And then here in this case, I'm on a Windows host. So what I need to do is that I need to download the Windows version of VirtualBox. Right now, it's this version here for me here. If it's a more recent version, when you watch this video, feel free to just download it. If there are any problems, I will make this clear here. So even if it's version 8 or 9, as long as I haven't added another text lecture here in this course, everything will still work as expected. So here I'm on a Windows machine, so I need to download VirtualBox for Windows. Don't worry, we can still install Linux inside that. It's just, we just need to select the operating system that our main computer uses, which is now Windows here. So I now click on Open File, and I want to confirm this. This is, by the way, multi-user on Windows. We need additional privileges here in order to execute this. So Windows is a multi-user operating system. We can see it here. I click yes. And now all I need to do is click through this assistant. So I click next. Here I can just leave it at the default settings. They are all right. Also, this one here works. I should be aware that maybe my network connection might get disconnected and then everything will work again, but it warns us. So if a download is running right now, you should wait with this install until the download finished. Then here I just click yes, and then I click install to start the install procedure. This will now take a little bit, and I can now just wait. Now the install procedure is done, and I can just tick the checkbox here, or it was checked for me by default, and I can now click finish here. Now VirtualBox will start, and I can now start using it. So how do I use VirtualBox? Well, for this, I need to be in the Oracle VM VirtualBox Manager here, and this will be the application that will allow us to create those virtual computers. Here, by the way, one thing. We will soon, in the next lecture, create actual virtual computers here, but there's one thing that I do need to mention here. In my case, the font was extremely small. It's still quite small, but it was so small that I could barely read it. And if that's the case, you do need to go into the preferences here and then go to display and then be sure to put font scaling to the max. I put it to the max. I feel like it's still slightly small. I would prefer a larger font size, but nonetheless, I'm able to read it and I am able to work with this. So I just feel like I do need to mention this, but probably this depends on your system configuration. So this is now the tool that will allow us to create those virtual machines. We can also see this here, that we can just add additional virtual machines here. Now we need to get our Linux operating system into this virtual machine here, or we need to create one and then get our Linux operating system into that. But because this procedure is slightly different between Ubuntu and CentOS Stream, I have to split this into two separate guides. So first you will get the guide for Ubuntu, and after that I will provide you with the guide for CentOS Stream. Let's now have a look at how we can install Ubuntu. And to install Ubuntu in our VirtualBox, we need to download the Do Ubuntu desktop image. This image contains the whole operating system, including an installer. So usually, if we still had a computer with a DVD drive, we would burn it on a DVD and then boot from that DVD, and then we could install that on a real computer. Or nowadays, usually we do not have a DVD drive anymore, then we would need to put it on a USB drive and then boot from that. However, we do not want to install Ubuntu on a real computer. We want to install it on our virtual computer. And luckily, VirtualBox can take care of this install procedure for us. So all that we need to do is that we need to go to ubuntu.com and download the latest desktop image from there. Important, we will be using the LTS version of Ubuntu in this course. LTS stands for long-term support. Usually an Ubuntu version is released every 6 months, but every 2 years they are releasing an LTS version of Ubuntu that is supported for a longer period of time, and this allows me to have a more stable base so that I don't need to update my course every 6 months and only every 2 years there's a new version here. If there's a new LTS version, you can just use that one. If there are any differences, I will have added text lectures here in this course, or I will have changed the videos accordingly. So this course is up to date, even if here in this video I'm still working with the previous LTS version. So I will be using the latest LTS version of Ubuntu in this course, and you can do too, whatever is the latest LTS version. Let's just have a look at this. And for this, we need to go on the website of Ubuntu, and then we can just click download, and then we want to download Ubuntu Desktop. So I click here, then I need to scroll down a little bit, and then I want to download the latest LTS version. This would be 22.04.3 as of now. Again, probably a more recent version when you will be watching this course, but again, if there would be any changes, this course would be adapted to them. So now we can see the download. It will take, here in this case, about a minute. It depends on your internet connection, so I will now just wait. Now that this image has finished downloading, I can go back into my VirtualBox here, and I want to now create a new virtual machine. For this, I switch to the welcome screen here, and then I just click New to create a new virtual machine. I will call my virtual machine Ubuntu LTS. By the way, in case this menu here looks different on your machine, there's an expert mode here. Maybe it looks like this. If it looks like this, then you can just click on guided mode. This one is definitely enough for us. Now we want to, I need to type it in again. I will call it Ubuntu LTS. And what I want to do now is that I need to select an ISO image first. So for this, I now select Other here, and I go into my Downloads folder and I just select my ISO. Then I want to tick this checkbox here. This is extremely important because otherwise VirtualBox will try to install everything for us, but by doing that it will do some problems or errors here. For example, the language settings weren't configured properly. This would prevent apps such as the terminal from launching. And the user wouldn't be configured correctly. If you have used Linux before, the user would be configured in a way that sudo doesn't work. If you have never used Linux before, don't worry about this. We will get to this later here in this course. So what's important for now is that we tick this checkbox and then click Next. Now we need to configure our virtual computer. Here in this case, it suggests 2000 megabytes of memory. Here in my case, I have way enough memory here on my system, so I can just give it significantly more memory. But anything above 512 should already be enough. 1 gigabyte would be better. If you can spare 2 gigabytes, that would be great. Here in my case, I don't need to care about this, so I can allocate quite a bit of memory to this machine. Also here, how many CPU cores do you want to allocate to this machine, or up to so many CPU cores it can then use. Also here in my case, I recommend 2 or 4 if you can spare them, and this should then definitely be enough. Then I click Next. We now also need to create a virtual hard disk. Here in this case, 25 gigabytes is actually a little bit at the lower end. I recommend something like 100 gigabytes at least. Here in this case, the way it works is that the hard drive only needs space if we actually use it. So we can just create it with 100 gigabytes for now, and this hard drive will be a file on our Windows computer here, and this file will only grow in size when our virtual machine actually needs that space. So it doesn't hurt to use a larger number here. The next thing is that I can just click Next and then Finish, and now this virtual machine will boot, and I can now see if everything works here. So now we can see it's powered off, and I now need to start it. Oh, it doesn't start automatically, never mind. So now the virtual machine is booting up. I got like several of those messages here, just confirm with yes. And then at some point we are here in our virtual machine. By the way, once you clicked into that, your cursor might hide. In order to return it, the default configuration is Control and Alt, and you need to press those 2 keys at the same time, and then your cursor is back in Windows. I had to change it here because my Windows machine is in another room and I'm just connecting it. You can also go into the settings here to change it. That would be in the Preferences, and then through Input and then virtual machine, you could change this host key combination to something else in case you are not able to press those keys properly. Never mind. Nonetheless, once I click now here, you can see my mouse is now locked, and I'm now connected directly here to this virtual computer. To go out, in this case here, I just need to press this key again that I selected there, or Control and Alt, depending on the default configuration. Now I want to select Try or Install Ubuntu, and now here my Ubuntu should boot. So here we are. First I will now close this menu, and we are now here in an install menu. I now want to install Ubuntu here, so I click on Install Ubuntu, and I now click through this install guide. The first option here is the keyboard layout. I highly recommend you to be really careful here. So here you can choose the keyboard layout that you want to use. And for example, on my case, I'm used to the German keyboard layout. So I should look, not detect here, I need to click through here. Let's see where we find German here. In my case, I need the German and the Macintosh keyboard here. In your case, this will probably be something different, but really be sure that that you select the right one here, because otherwise different symbols might not work as expected. So here in my case, I do need to select this. And the next thing is that I want to select here is that I want to do a normal install, and I also want to install all the updates already while installing Ubuntu. Third-party software for graphics and additional things, I do want to include this. Maybe it will install a little bit more there, but it can avoid any problems. This is a separate option because some people only want to use open source software, maybe due to licensing reasons. So it's important that this is a separate option. But here in my case, I do not need to worry too much about that. Then I click continue. And now I need to just see what's the next step here. It's preparing now everything. Let's see, now we want to erase our disk and install Ubuntu. We do not need to go into the advanced features, we can just install it. So I now click install now and continue, and now I just need to, I still need to tell the system where I am, and then I need to provide my information. Here in my case, I will use my real name here. Then my computer will get a name here. This might be important later if we want to connect to this computer from another computer. So I will call it Janus-VirtualBox. This looks good. Then I also need to pick a username, and also I do need to pick a password here. I will also choose that I want to be logged in automatically. This is all right here, because in order to run this Ubuntu, people need to be logged into our Windows anyway, and once people have access to our Windows user account, then pretty much there's no additional, there's nothing preventing them to also access our Ubuntu. So here in this case, be sure to pick a password that you can easily type and easily remember. It's not really for security because this is not a real machine, at least for now. It's for now also not visible in the network. So here I would recommend you to pick something simple and something that you can type easily. We will need to use this password quite often here actually. Now I just press continue, and now I can just wait until the install is complete. Once the install is complete, it should usually only take like 10 minutes or so. We can click on this button, restart now. Now we can see here, remove the install medium. That's all right. We don't need to do this. We can just press enter, and this should be enough. And now we can see here that we are now booting into a real Ubuntu. So here we can see the boot procedure. I want to make this a little bit bigger here. And there we go. Here we are now on our Ubuntu system. We can see here, in my case, it has been configured in a way to automatically log me in. And I now want to use this Ubuntu system here. We see that we start with this assistant here that we can just skip, and we can press next, and here next again, and we are done. And this is now here our installed Ubuntu system. By the way, just a really quick heads up. If at the top right corner there's no power button but a battery symbol, this is totally alright. It just means that your virtual machine software provides power information about the battery state to the virtual machine. So if the top bar looks slightly different, that's totally alright. There are two more things that we might need to do here, aside from installing those updates here. Aside from that, we still need to see how can we stop our virtual machine, how can we create a so-called snapshot, and there's also additional software that we still need to install to make it really easy to use this virtual machine. So there's still a little bit of configuration that we need to do, and how we do that, this is what we will have a look at in the next lecture. In this lecture, we want to have a look at how we can manage our Ubuntu virtual machine. And for this, in this lecture, we will be configuring Ubuntu, which pretty much means that we will need to install some drivers first to be able to work smoothly with our virtual machine. This will then allow us, for example, to have a clipboard to use copy and paste. If it would work, we could also drag and drop files. If it doesn't, might also happen. And we will then also be able to enable shared folders that we can access our Windows or at least a folder from there from our virtual machine. For this, we will need to update our system. We will then need to install the tools required to compile those additional drivers. Compiling means that those drivers are available, but in source code. So we can't just execute this source code and run it on our system. We need to compile it, which means that we need to make those drivers executable, or at least we need to be able to. The install procedure then will take care of that. We luckily don't need to do much here manually. So we just need to have those tools installed, and then we can immediately install the drivers. Some of this stuff we will already do on our terminal. Don't feel discouraged by that if we are now using commands that we haven't really examined that much. The reason is that first priority now is to get our system running, and then we can start looking into those commands and how everything works later here in this course. So here we will be configuring Ubuntu, and I will show you how you can utilize this virtual machine. So one thing that we can see here is that this is now a running computer, but there are a few things that are not really convenient. Let's say, for example, we had a folder here, maybe just a new folder. I can't just drag and drop this into my Windows. This just doesn't work. And this can be extremely convenient or really important because maybe you want to add some data from your Windows into this virtual machine. Also later here in this course, I will be giving you exercises, and then you need to work with data that I provide to you. And for this, we do need to install additional drivers here. But unfortunately, we can't just install them directly. We need to update our system first, and we need to install some really essential software so that we can install those additional drivers. And for this, we need to go to Show Applications, and then we need to open a terminal. Here, we need to make sure that our system is up to date. So I do a sudo space apt space update. We will have a more in-depth look at how we can manage our software on our system pretty quickly, pretty soon here in this course. For now, we just need to get our system running, and unfortunately, we do already need to use the terminal for this. But what this command does is that here we want to use additional privileges for this. apt is the program that we want to call. This is responsible for managing the software on our Ubuntu, and we just want to see what updates are available there. So I execute this, then I type in my password, and then we just need to wait a little bit until everything here has been downloaded. Now the next thing that I need to do is a sudo space apt space full minus upgrade to issue a full upgrade here of my Linux system. And here in this case, not much or nothing is being installed here. So this is all right. No updates here have been installed. This is what's important. If it did install updates here, be sure to restart your computer because maybe it updated the Linux kernel. And in that case, it would be best to just restart your virtual machine. You can do this by going to this menu here, then power off logout, and then clicking restart. Here in this case, no updates have been installed, so in this case, no need to restart. The next thing is that I need to now install a few additional software packages. So what I want to do is that I first type in clear and then press enter to just be able to start from scratch here. And then I want to install additional software. And what I want to install is sudo apt. I want to manage my software somehow. I want to install some stuff. And what I want to install is called build-essential. Then I want to also install something that is called Linux-headers-generic. And I also want to install something that is called DKMS. It stands for Dynamic Kernel Module Support. We do not need to get into the details now, though, of course, there will be a chapter about kernel and how everything there works. But for now, this is just the command that we need to execute here, and we need to confirm this. We can see it wants to install quite a bit. This is all normal. It might be also a little bit more or a little bit less. This really doesn't matter. We just confirm with a Y, and then we wait a little bit until everything has been downloaded and installed. So now we can see here it's installing quite a bit. What we are installing now is pretty much all the tools that we can use, or that we can take source code and we can turn it into executable files. And we install also all the tools that allows this code to integrate into the lowest level of our operating system, our kernel. So this is what we are doing here, because those drivers, we can't just install them. They are open source, but not in binary form, but in source code form. So we need to have the tools here to turn this source code into executable drivers. And this is why we needed this many additional programs here in order to facilitate that we can do this. Now the next thing is that we can go here into our menu and we can click on Devices, and then we can click on Insert Guest Edition CD image. This will pull a CD image into our virtual machine that then here will give us this CD image here. We can access this to our virtual machine. This looks like a normal CD. And here we can see we got a one.run file. VBox Linux editions.run, and this is the file that we need to execute. We need to execute this from our terminal. So what I need to do is that I need to say sudo, and then I just drag and drop this file. It must be this file. It can't be the other one. It really must be this file, and then I just drag and drop it here. Then I just press enter, and now we want to continue here. Here in this case, I've tried to install it without installing the additional software, and then during the install it failed. So this is now here my second try, but there are some parts that are already installed, so I get a warning here, but I want to wish to continue anyway, and I want to reinstall everything here. In your case, this would be the first install, and probably you would not be asked this question here. We can now see here, it may take a while, this is completely normal. It's now installing those drivers into the lowest level of our operating system, and then everything should work smoothly from there on. Please be aware that if you do certain upgrades and it upgrades this lowest level, the so-called kernel, you might need to redo this. So if some point in the future a drag and drop or features like this would not be supported, then be sure to rerun this install procedure. So now those tools are installed, and now what I want to do is that I can now just restart here my Ubuntu virtual machine. So I click here on restart, and now I can just wait a little bit until this is restarted. So here we can see it's booting now, all looks good. Let's just wait a little bit until it's back up again, and then we can see here we are back here, and this is now our system. Now let's see what additional features we got available. We need to enable quite a few of them, so theoretically we would have a feature to enable drag and drop. I've tried it though, I do get an error then. Let's see if I can drop something into my virtual machine. We can see here this also doesn't really work, the drag and drop support. We do get an error message here, but theoretically I should be able to enable that, and hopefully this is a bug that's fixed when you will watch this video. But we have other things that do work here. For example, I can make sure that shared clipboard is set to bidirectional. And this is not meant for files, but if I were to edit a text file here, for example, so I've just opened a program here called Text Editor, here, this one. And if I had a text file here, for example, with hello, I could now just copy that, open something here on Windows, for example, the program Notepad. Now I had a Windows application here, and I could now paste this. So this is already quite nice. So my clipboard is now shared with my virtual machine. Another thing that's really convenient, which will allow you to get data into this virtual machine, is that you can also share folders here. We can now go to shared folder settings here, and we can now configure that I want this virtual machine to be allowed to access certain folders from my Windows machine. For this, I can add a shared folder here, and as the folder path, I will just select my desktop. Now I can press here, select folder, to utilize this folder here, and then I can call it desktop here, and I could say, okay, my virtual machine should only be allowed to read to this folder, or whether the virtual machine should also be allowed to write. Then here I would recommend to check this option. This means that this is permanent and will automatically have that folder available. And here, oh, and I should also make this permanent here. Otherwise, it's only temporarily. Now I can press OK, and I can now confirm this with another click of OK. Now, back in my virtual machine, I can now open my Files app here. And if I go into my Files app, we can see here, I have now access here to, or I'm now allowed here to access the desktop here by clicking there. I need to go through other locations here though. Then I need to click this on this once. And then I do need to enter the user's password here again. And the user here, or the password that I need to enter, is the password of the user of the virtual machine. I did now need to enter this 2 times. I'm not entirely sure why, but now I do have access here to the contents of my desktop, of my Windows desktop. And I could now, for example, create a new folder here, create it. And if I would now go back here to my Windows desktop, we would see here there's now this additional folder here on my desktop. So this is how you could get data in and out of this virtual machine, even if, for example, the shared, the drag and drop does not work. So now we are having a virtual machine that is kind of isolated, but nonetheless, here we still have the possibility, well, not really through this one, but through other locations, and then this one here, to still access files from our Windows host. And this can be useful for getting data in and out of this software here. The next thing is that when you are done, you might want to just shut down this computer. And you could do this through just powering this computer off. But you can also just press this X here, and then it will ask you what you want to do. You can do a normal power off, but you can also just pause it. Because this is a virtual machine, we can just pause it and then continue running this virtual machine at a later time. So I can just click here, save the machine state, and now it's saving the current state here. It takes a little while because it now needs to use all the memory, or take all the memory and store it on disk. And now we can see here, this has now a saved state, and we can now just resume it at any time, and this can also be extremely useful. So now you got a working Ubuntu here that we can now use here for the rest of this course. So this would be the complete install of Ubuntu Linux within VirtualBox. I now want to give you a quick outlook. So first of all, congratulations, you now have a running Linux system that you can use for the rest of this course. Feel free to play around a bit and discover on your own how things work. This is completely optional, but feel free to take 5 or 10 minutes at least to play around, maybe even more if you feel like it. This is now great because now we can have a solid base to really start exploring Linux. And I mean, for this, of course, we need this running Linux systems. So now we are prepared for the next chapter, in which we will have a look at the principle of Linux, how everything works there, and we will also start to explore the terminal and how that one works. So stay tuned. You have already achieved a lot. You have now a running system that you can build upon for the rest of this course here. So stay tuned, and in the next chapter, we'll continue. A quick interruption. If you want to learn more, this video here, it's just an excerpt of a 70+ hour long course about Linux. In this course, you will learn way more about Bash command line. For example, we will configure your terminal, or we will have a look at how colors work and everything like that. But you will also learn everything you need to know about Linux and how you can write Bash scripts, for example, a backup script. This course is super extensive because I decided to add so many different topics into this, so this is really the complete guide if you want to master Linux. In this course, you will also get quizzes, exercises, and a question and answer area. This is something that I cannot provide to you in this YouTube video here, unfortunately. So if you're interested, be sure to scroll down. I have provided a link for you there. However, let's now continue here with this video, and let's now get you started with using the terminal. This chapter is all about the first steps in the terminal. In this chapter, we will first have a look at what is a shell, because there are different definitions out there. So we first need to clarify the term, what is a shell, and how can we then use it. We will then go through a quick history of different shells, for example, SH, Bash, and ZSH. There are different alternatives to Bash here. The problem is that they might look pretty much identical, and then later on in this course, when you try to execute certain commands, they might work completely differently than in my video. So we need to have a quick look at the alternatives to Bash and how we can confirm that you're actually running Bash, and also running Bash in a version that is supported here and not like an outdated version, as for example Mac users might do by default. So we will have a look at the quick history of those shells, and also we will ensure that you're actually running Bash. We will also see how you can configure the terminal, meaning how you can change there the font size or the font so that you can confidently and seamlessly work with the terminal. We will also then have a look at how we can execute our first few Bash commands. So in this chapter, the goal is to get your hands dirty and to get you started to use the terminal. So let's start this chapter by having a look at what is a shell. In this lecture, we want to answer the question, what is a shell? And first, I want to give you the general answer because I want to be exact here. I want to be accurate here. And in general, a shell is the outer layer of an operating system. The outer layer usually takes commands from users and translates them into a form that the kernel or that the hardware can understand. It can then also display the result of those commands to the user. I want to specify here that this is the general definition. So everything that allows the outer world to access the operating system is considered a shell. So the graphical user interface that you can see here, for example, this is considered a shell. Also, if we had a web server or we had a server that would deliver a website to users, then this would also already be a shell, because users from the outside world, that could be me trying to download a file, accesses this server by requesting the download, and then the server answers with a reply. That would then also already be a shell. So this is the general technically correct definition. However, most often when we talk about a shell, we mean the command line with it. So quite often the term shell only refers to the command line interface of an operating system. Command line interface is a text-based interface that allows users to interact with systems by typing commands. We have already used this interface previously during the install of our virtual machine because we had to fix some problems there to make it work with our virtual machine software. Thus, the term Linux shell usually only refers to the command line or to the terminal or console or however we want to call it. Thus, the shell on a Linux system, in more common terms, or the definition that's more often used, the Linux shell is just this text-based interface that allows us to work on devices that don't support a graphical user interface, or we can just work more efficiently with our system. So in our case here, this would already be a shell, according to the technical definition. But more commonly, if we talk about a shell, we pretty much mean the terminal app or what's running inside this terminal app. This is what we commonly refer to when we talk about shell. Just be aware that there's the technical definition that includes way more, and the more commonly used definition that only this is considered a shell. So now we know what is a shell. The next thing that we need to have a look at is what different shells in the more common sense or more commonly used sense are there, because certain operating systems might ship with different shells or text-based interfaces here by default that all will look extremely similar, and it's important for us to differentiate between those, because otherwise maybe you're running something else than a bash here by default, and it completely looks exactly identical or almost identical. And to prevent this, because then you would not have a great experience here in this course, because certain things will then work differently on your system. We will have a quick history lesson about shells and how everything worked there. And after that, then we will talk about bash again. Let's now have a quick look at the history of commonly used text-based shells and how this has developed here. And I want to emphasize that there are many different shells available there. And here in this term, I use shell more for the commonly used, or the way how it's commonly used for like text-based interfaces. So depending on the operating system, we have different shells available there. Let's go through the most important of them, and let's first focus on Linux. There's, for example, the Bourne shell, and this has been developed in 1979. Of course, the development has continued, but this was the shell that was the default shell in Unix 7. Unix 7 has been released in 1979, and with that, the Bourne shell was introduced. Unix was this operating system that's, well, GNU Linux is not a copy of that one, but it's heavily inspired by that. So this is the relationship to that one. Back then, it was known as the program SH. This is important because even nowadays, we would be able to launch this program, and it would then try to emulate a Bourne shell. Then we have Bash. This was meant as a replacement for the Bourne shell, and this is where the name comes from, Bourne Again shell. The development started in 1989. It's the default shell nowadays for many Linux distributions, and it's open source software released under a GPL license. If we nowadays start an SH shell, we usually then start a Bash. It might have certain compatibility modes there. It does depend a little bit on the configuration. Then we also have another important shell that's really common, that is the Z shell, ZSH. The development there started in 1990. It's also an open source software, and it's nowadays also the default shell for various Linux distributions, for example, Kali Linux, and also for Mac users. If you're a Mac user, you might be running ZSH if you launch the terminal app on a Mac. Be aware, there are more shells that are commonly used on Linux systems. I needed to make a selection here, and I decided to only include 3, but be aware that certain Linux distributions might be running a different shell, but how we can make sure that we are running a Bash, we will also have a look at this here. However, there are more shells that are available. So, for example, Microsoft has also released quite a few shells, and one would, for example, be the command prompt. It started in 1987, developed by Microsoft, and it allows us to use MS-DOS commands on a Windows computer. It's completely different than Bash. So if I was here on a Windows, for example, and I would launch the command prompt, this would be completely different than the Bash. So please do not confuse this. This is really something completely different, this command prompt here. The next shell is the PowerShell. It was released, the initial version in 2006, also developed by Microsoft. It's nowadays also available for Linux and macOS. It uses different commands than Bash, but it's a little bit more confusing even, because quite a few commands are working pretty much the same as on Linux, but then a lot of commands work completely differently, or the output is different. But at least some commands there are somewhat similar. So here you need to be especially careful. So here, for example, if I would now open a PowerShell here, this would be, again, completely different than the Bash, though certain commands might also work here. But I really want to emphasize this. This does work differently, so please do not run the commands for Bash in a PowerShell and expect everything to work there. So now the question, of course, is why should you learn Bash and not one of those other shells? And this I want to answer in the next lecture. Now that we have seen that there are many different ways for text-based interface or text-based communication with your computer, why should you learn Bash and not one of those other shells? Well, Bash is the most common command language used in command line interfaces. We can easily launch Unix tools and combine them together with so-called pipes or redirects, but we will have a look at this later. So for now, it's just important that we can launch Unix tools and combine them together and pretty much write what we want to do completely ourselves. This allows us to be extremely efficient in what we write. So sometimes we can have just like one command on our command line, and it does as much as maybe like 5 or maybe 10 lines of Python code. So Bash allows us to be extremely efficient in what we write, and this gives us a lot of power. We can also write our commands down and turn them into a so-called shell script. Shell scripting is pretty much the part 4 here in this course. First, we will just have a look at how we can use this command line. Then we will learn about Linux, and then we will learn about shell scripts. But I need to give you a little bit of a heads up. You know, at the slide before, I said that Bash is extremely powerful. With great power comes great responsibility. The syntax of Bash is extremely short and compact. Slightly different commands can mean something completely different. Example, there's no need to understand it for now. Those 3 commands here would mean something completely different, and they would do something completely different on your system. Again, there's no need to understand this for now. We will look at exactly this example in a later chapter. It's the chapter about expansions, but it doesn't matter for now either. But all that matters is that we see there are those double quotes here, there are those single quotes here, there are no quotes here, and those are 3 completely different things that I have provided there. So this is what I mean with Bash can be extremely short and compact, but different commands or just slightly different commands can mean something completely different. Thus, the way to go for Bash is that it's important to focus on deep understanding here in this course. There's no reason for me to be like, hey, those are like the 20 commands that you need to know and now just do your thing. What's important here in this course is that I will teach you everything step by step, but that I will also help you understand the differences here. So I will point out those differences quite often here. I will point out what are the best practices to avoid common pitfalls. So we will focus on a deep understanding here in this course, and I will guide you through everything here step by step, so that at the end of this course you will have this deep understanding of how everything works. So we can see Bash gives us a lot of power over our system, but now we want to start using Bash. And for this, we will need the terminal app, and how we do that and how we can configure everything there. This is the topic of the next video lecture. Let's now have a look at the first steps in the terminal. And for that, we first need to open our terminal app. On CentOS, we can just click here into our menu, and then down there, we can just launch a terminal, and then we can see this is now here our terminal. On Ubuntu, it looks slightly different. If I go here into my Ubuntu, we can see here I need to I can click here on activities, but nothing happens here. The way to launch the terminal is that I need to click here on show applications, and then I need to look for my terminal app, and then I can just launch this terminal with a click. One thing I want to emphasize here, those terminal apps might look slightly differently. So if I would go here, we can see this terminal app looks differently than this one. This is completely normal. Later here in this in this course, we will have a look at how we can configure the look and feel here of our terminal, how, for example, this one here will look like, which colors are used there, and all of that. For now, we can just leave it at how it is. One thing I do want to emphasize here is that this is now just a normal text-based interface to our computer. That means we can type in some text here, for example, hello world. I'm not saying this is now like a super valid command. We can see here there's even an error then printed. But what we can see here is that we can print out, that we can enter something here, confirm this with an enter key, and then it's trying to do something here, and in this case with hello world it doesn't really know what to do, and we can see there's an error message here. We don't need to have a more in-depth look at this for now. We will have a look at a more proper way how to output something here pretty soon. There's one more thing that I want to emphasize here. Here in our terminal we can go into the right click and then into the preferences. This allows us to configure this terminal. I highly recommend changing this a little bit. So for example, in my case, I like to set a custom font, and in my case, I really like to increase the font size because then it will look better here in the video. Then you can also change the colors, and for example here I might change the colors to like a more bright setting because I feel like then everything is better or is more readable here in the video. So feel free to play around here and choose something that you like. There are different ways you can use here. Maybe you like this style of a terminal the most, then just use this one. It doesn't really affect the actual stuff that we are executing in this terminal. I will now choose another color scheme here because I really want to make sure that it's well readable. I think Gnome Light would be a good way to go here for me. One more thing before we look into how proper commands work. One more thing that I want to do here in this lecture is that I want to confirm that you're actually using bash. The reason is that certain Linux distributions might have different default shells, or maybe you are running a different Linux distribution and maybe it's not having bash as a default shell. So we should confirm this, and usually this way is the best way to confirm it, that we just say echo and then double quotes, then a $, then those curly braces, and then bash_version, curly brace close, and then another double quote here. And this should output something if we are running in a bash. Let's just have a look here. I can now just say echo and then here bash_version, and then I just execute this. Then we can see here, as of now, I'm running here in this version. Be aware, everything above 5 doesn't really matter. So if I'm running 5.1 here, that's all right. If maybe in the future there's 5.8 released, this will be all right. Or even if you're at some point running version 6, this is also all right. Whenever there's a major update for Ubuntu or CentOS, I will make sure that this course is up to date. So this just happens to be the version that I'm running here right now. By the way, really make sure that everything is exactly identical how I've provided it here. If you have struggle typing in those characters, be sure to go into your settings here and then into the keyboard tab, and be sure to select the correct input source. So if the keyboard doesn't work properly, then the keyboard isn't configured properly and you need to change to the language of your keyboard. In my case, I'm used to the Mac German keyboard, so I need to select German Macintosh here. In your case, it will probably be something else then. Let's now go back to the slides. If it doesn't output anything or just an empty line, then it's important that we launch bash with the following command by just typing in bash and then hitting enter. And for now, you need to do this anytime you open a new window or a new tab in your terminal. So here in this case, it is bash. So I could just open a new tab here, and this is now bash. So I don't need to do anything here. But let's say, for example, my default shell was something else. Here on Ubuntu, if I run sh, I do not launch a bash, at least in my configuration. It's a different shell. It's called dash with a D at the beginning. And I could just launch this. But let's say, for example, my terminal would launch in this view here. We can see here it looks different, but it would not necessarily need to look different depending on how this dash is configured. But if my terminal would launch like this, I could find out, for example, here, if I run this command here, that I'm not running in a bash because this doesn't output anything. In that case, I would then need to enter bash and then hit enter to actually end up in a bash. So if your terminal launches in this view, you need to enter bash and confirm this with enter to actually end up in a bash. And now we can confirm that we are actually in a bash by outputting this variable, and now everything works. Be aware here, those are all independent terminal sessions here. So that means if I open a new tab here and this was not in a bash, then you would also need to enter bash here and confirm this with an enter. Here in my case, the default is a bash, so technically I do not have to do this here. Nonetheless, be aware that you do need to do this then every time you open a new tab or a new terminal window. All of those are completely independent. What you do here doesn't influence what you do here, and vice versa. Later here in this course, we will also have a look at how you can change the default. But for now, if this is not a bash, then be sure to always launch a bash by typing in bash and then hitting enter. So now we have confirmed that we are in a bash, and I would say let's now start writing our first real bash commands. Let's now have a look at a first command that we execute in the terminal. And for this, I want to introduce you to the command echo. This allows us to output text in the terminal. We can test this by just saying echo and then bash is amazing. Please note here, for now, the string that we want to print should be wrapped in single quotes. In bash, they don't necessarily mean that we define a string as another programming language. They mean something else, those single quotes, but nonetheless, they are really important for now. But don't confuse the quotes in bash with quotes from other programming languages. They work completely differently here in bash, but we will learn more about that and the reasoning behind that in the chapter about expansions. So for now, it's just important that we really write it exactly how I put it here on the slide. So if we just execute this here, echo, bash is amazing. And then I can just hit enter. Then we can see here, this is the output that has now been generated. The way it works here is that the first thing that we write here, this is considered the command or the program that we want to run. And everything after, it's considered that those are the so-called arguments to this command or to this program. So echo is our command and everything behind this are our arguments. All in all, we can then also say that everything here is one bash command, so this would be our whole bash command. Let's have a look at this again. So here, this would be our command that we want to do. This is our argument. Here in this case, we only have one argument, which is bash is amazing, exclamation sign. And if we execute this by hitting the enter key, then we can see here our bash command has now been executed. There are more things that I want to emphasize here. By default, echo will output a line break at the end. We can disable this with the option -n. So for example, if we would run something like this, then we would it would not print a line break after. Let's just have a look at this. Here I could now just type in everything again, bash is amazing, and just press enter to execute it. And then we can see here after this, it has not printed a line break. And this is now why my terminal here starts without a line break. This is totally all right, by the way. Usually all the commands that we execute, they usually output a line break at the end of them. Here in this case, this didn't happen, so our terminal now starts here in the middle of a line. This is completely normal, and this is to be expected. By the way, instead of typing this again, I can also use the arrow key up to just go through my history. And here, for example, I can see the commands that I typed in previously, and I could just select one and then, for example, edit this, add this -n here. Again, I navigate through this command with my arrow keys, and then I can just add something here, and then I can just re-execute the same command. Or I could also now, for example, here, go one letter to the left, add a few more exclamation signs, and then press enter, and there we go, this one here has worked. By the way, sometimes if we are starting here in the middle of a line, it might be that it didn't show that I entered multiple exclamation signs here. In that case, the solution would be to just press enter again, that we start in a new line here, and then go back, and if I would now hit the exclamation sign multiple times, it will also show appropriately here in our command. Just be aware, if you're not starting here from the beginning in the line, it might not show if you press this exclamation sign multiple times, but it will still count. So here, for example, if I would go back here, back to this one, I would go one to the left, and I would now press the exclamation sign multiple times. Here in this case, it now did show everything properly, but here before you can see it didn't show everything properly, and this was because the command started within a line. So those would be considered so-called options. So we have our command, that's our echo. Then we have an option here. The option is sometimes also considered to be an argument as well. So we can see it in both ways here. And then what we actually want to print, that would be bash is amazing. But there's one more thing that I want to emphasize. Usually, a lot of those commands have different options available. And one additional option is the -e option. This enables \escapes. Let's have a look at this. So for example, here we would output something that consists out of multiple lines, and we can indicate that we want to put a line break here in between by using \n. But in order for this to be converted into a normal line break, we need to also specify the -e option, otherwise it will just stay at a \n. Let's just have a quick look at this. And here I'm in my terminal again, and I want to just clear my screen to show you the next example. For this, one more command is the clear command that I can just enter here and then confirm with enter, and this will just clear my screen so I can start from scratch again. Now I can try echo here, and I could, for example, say here, echo bash is \n amazing, for example. And if I would now just execute this by pressing the enter key, then we can see here it's now just printing this one. But if I go back with the arrow key up, now I use the arrow key to go to my left. And if I now enable this -e and then a white space here, then I can press enter again. And then we can see how this \n, this so-called \escape here, is converted into a line break. And this allows us now to print this here in multiple lines. This is usually the structure here of such a shell command. We have a command that we want to execute. Then we have one or more of those options. And then quite often we do have those arguments. Of course, sometimes we only have a command that we want to execute. Sometimes we don't have those options. Sometimes we don't have here additional arguments that we want our command to work with. But this would be like the full structure here of a command in our terminal. And we just confirm this execution by pressing the enter key. One thing I want to emphasize is that you can also combine those options. So for example, we want to combine this -e and this -n, then we can just combine them. So we could say -e and -n, and this would then, for example, here -e would enable that we can use a \n here, and -n, as we have seen before, would disable the line break at the end. Let's just have a quick look at this. I go back here. Here in this case, I will leave it at bash is \n amazing. I want the \n to work. And I also want to prevent that echo outputs a line break after it. So I can just execute it like this, press enter, and then we can see here a line break at the end now here has not been printed here. But I want to emphasize here that we have different ways to combine those. We can also usually just write all of those options in one block. This is just a shortcut here. And of course, the order here of those options usually also doesn't matter. Why usually? Because this is part of the responsibility of this echo command to understand everything correctly. And depending on how that is coded, it might not be supported. So this depends on the command that you execute. But most Unix command, if they support options, you can always combine them. But again, it does depend on the command. So every now and then you might find commands that require, for example, this format here of options. Let's have a look at this. If echo here allows us to combine it, so I press the arrow key up, then I go back, and now I just combine all of those options. And as you can see here, it's now still working exactly the same. We are able to output bash is line break amazing, and after that it's not adding a line break. This might seem like a simple example here, or maybe you're like, okay, why is this so important that I can add line breaks here in between or prevent the line break here? And I need to tell you this is sometimes important, because later, for example, we could take this output and write this into a file, but also the concepts here are extremely important, that we have a command, that we have options here, and that we then have arguments here to our command, and then everything is executed here. So this is extremely important also from like a concept here, and it's important that we introduce this now. The reason is that we now want to start building on top of that, and in the next video lecture, we will have a look at how you can navigate the file system. A quick interruption. If you want to learn more, this video here, it's just an excerpt of a 70+ hour long course about Linux. In this course, you will learn way more about bash command line. For example, we will configure your terminal, or we will have a look at how colors work and everything like that. But you will also learn everything you need to know about Linux and how you can write bash scripts, for example, a backup script. This course is super extensive because I decided to add so many different topics into this, so this is really the complete guide if you want to master Linux. In this course, you will also get quizzes, exercises, and a question and answer area. This is something that I cannot provide to you in this YouTube video here, unfortunately. So if you're interested, be sure to scroll down. I have provided a link for you there. However, let's now continue here with this video and let's now get you started with using the terminal. Let's now have a look at how we can navigate the file system within the shell. And the first command that I would like to introduce you to is the pwd command. In our terminal, we are always in a directory. This directory is called the so-called working directory. It is the folder that the shell is currently operating at. Commands and also programs can access this folder and they can act relative to this directory. If we want to find out our current directory, we can just use the pwd command, and this stands for print working directory. Let's just have a look at this. Here I'm in my terminal, and anytime I'm in a terminal, I'm also in a folder. And to print out the path to that folder, I can just use pwd, and then we can see the folder here right now is home / and then my first name and my last name. This is just my Unix username that I have here on my computer. This will probably be different. Also, this one here, this /home here, might be different. For example, on a Mac, it might be /users. This is the folder that I'm currently operating at. Please note that on Linux systems, we do not have drive letters. Everything is in our root folder. So I could also, for example, go into the same folder if I'm here in my file browser. And I would then, for example, navigate to my root directory through other locations. And then I navigate to my root directory, then into my home folder. And then this would be my user folder. So this is the folder that I'm currently at here in my terminal. By the way, if you're wondering how do external drives work if we don't have drive letters, well, they end up in this hierarchy as well. So for example, external drives, they usually end up here on our root file system and then either in this folder or in this folder. It depends on how they are being made available and how that is configured. But here, for example, external drives might show up in this /media folder, just as an example. So everything here is in this directory structure here on our Linux systems. But don't worry too much about it. There's a separate chapter about how files work on Linux, specifically on Linux, how the file structure works there. So we do not need to get into that for now. Another thing that I want to emphasize here is that certain shells might be configured in a way that they show us the current directory we are at. We can see this here. Here we can see that it's printing the tilde character, and this means that we are right now in our home directory, in our user folder. This is just the shortcut for our user folder. Just be aware that this highly depends on your system configuration, and this might change with an update, or if you're, for example, on CentOS, this stuff here before the command looks also different, and the shell might also be configured in a way that only $1 is shown, or that even nothing is shown here at all. So this is something that can be shown here. If it doesn't show, again, there will be a separate chapter how to configure that, but I want to say here, don't worry about that for now. Right now, this is the way that always works to print our current directory. But now that we've seen how we can see our current working directory, how can we change our directory? And for that, we can use the cd command. And this stands for change directory. And just a few examples. One way would, for example, be cd space and then the name of the directory. And then we would move into that specified directory. Just as an example, cd space desktop, for example, would move our terminal into the desktop folder. Let's just have a look at this. So first I will open my file browser again. It's now already here in my home directory in the home / and then this my first and last name as a username, but this will probably be different on your system. But here we can see we got a folder that's called desktop. And I could move into that by saying change my directory into my desktop folder. And here you can see that I kind of like magically typed it. And the way I did this is that I used a tab autocomplete. So I can just type the first 1 or 2 letters here, and then I can just use tab to let the system complete this for me. And here in this case, I could just change into that folder. This one here just means, I could change into that folder like this, or I could add another slash here at the end. It doesn't really matter. Now we are here on my desktop. We can see the way my terminal is configured. It shows me I'm in my home folder on my desktop. And if I now press P or enter pwd, we can also see that this path here has changed. Be aware, items that are on the desktop, depending on your system configuration, might be shown on your actual desktop over here. Here, for example, on Ubuntu, this is also completely separate, what's shown here, than what's in this folder here. Just be aware of that. This is now just a folder that we can access, and it doesn't necessarily mean that everything will show up on your normal desktop wallpaper as well. But what's important here is that this is just a folder that we can use, but again, we might need to use the file browser to list the contents here. But there are also other ways how we can use the cd command here. Let me go back to my slide, and one way would, for example, also be that we could provide an absolute path, and here we are just like, hey, I want to change into my so-called root folder where everything starts. If I navigate into that, cd/, then we can see if I now enter pwd, we are now here in this folder. Another way how I could also navigate into my desktop would be that I navigate with a long path into my desktop, so /home/ username /desktop. Also here I'm using extents, or I make a lot of use of the tab auto completion, and if I now hit enter, we can see here we are now back on my desktop. The next thing is that we can also just navigate a folder up. So this would be just like a cd ... and this would move into the parent directory. So that means, for example, here we are on my desktop right now. I could move into my parent directory, and now we could see I'm back in my home folder. Or I could even navigate 2 levels up by saying cd ... and now I'm in my root directory. So you can see how I'm able to navigate around here. Also, if I now want to go back into my home directory, I could then also just use cd and then the tilde character, or just cd without any arguments here, and this would move me into my home directory. Let's just have a look. Right now here I'm at my root directory, but I want to move into my home directory, so I need to enter this character. If I now execute this, I'm now in my home directory, but another way to do the same, I will now just navigate back into my root, would be to just use the cd command without any arguments, and then I would also navigate into my home directory. Or another way, of course, if I wanted to move into my desktop, I could also write it like this. This will resolve to my home directory, and then I would move into my desktop of my home directory. So you can see how you can combine all of those path names, and you can just use everything here. So this would then move to the user's desktop. So now you know how you can show the current directory that your terminal is working at, and you can also, you also know how you can change this directory. However, we now want to do something with those directories, so in the next lecture we will have a look at how we can list the contents of those directories as well. Let's now have a look at how we can list the contents of a folder. And for that we can use the ls command. This prints out the contents of our current working directory. Let's have a look at this here. Right now, I'm in my home directory. My terminal here is configured in a way that it shows me my current working directory, but I could also use pwd. And to list the contents here, I could now just use ls and confirm this with enter, and then we can see these are the contents of my home directory. Let's just confirm this. For this, I'll open my file browser, and here this is my home directory, and we can see those are exactly the same folders that are now also shown here on my terminal. Please note that depending on your system configuration, this might not be shown in colors, it might just be black and white. This is completely normal. This really depends on how your system is configured. Again, as you probably expect by now, more on that, of course, later here in this course. We can also add additional options here to our ls command. So the syntax is the following. We can add additional options here, and we can also say that a specific path should be listed. Let's first have a look at the options. -a, for example, will list all entries, including, for example, hidden files. Let's see how this works. Here we are in my home directory, and I can just say ls space minus or dash a and confirm this with enter. And then we can see that there are actually quite a few more folders here. Here I can see that it's a folder because it's colorful. This is what the colors symbolize, the type, whether it's a normal file or a folder. And we can see we do have those additional folders here and also additional files here that are hidden. Hidden files on Linux or on Unix systems, by the way, they always start their file name with a dot. So those are just hidden files. This is the reason why they didn't show up here in our file browser, because here by default, hidden files are not shown. But I could say here, I want to show hidden files, and then we can see those hidden files here are now shown as well. In this output, we can see here there are also those files or those folders that are now shown. The dot folder is just the same folder. Dot means just that we can go a level up. They are just included here in this output as well. But aside from that, those are now here all the documents or all the files and folders in my home directory. Of course, I can now also just change into a different folder, for example, in my root directory, and there I could now just execute the same ls command again, and then we can see those are now the contents of my root directory here, of my file system. The next thing is that we also have additional options here available, for example, -r to reverse the order. Then it will no longer be ascending but descending alphabetically, or we could also, for example, sort by modification time. Let's just have a look at this. So here I will move back into my home directory. I will clear my terminal so I can start over again. And I will now use -t because I want to sort by the time. And then we can see here now, well, this is now sorted by time. We can also reverse the order by adding an R here. So I could say -r space -t, or I could also, for example, just write it like this. This would be completely identical, and then we are just reversing the order. So you can see here how we are also using those options here and how those options can be combined. Another option that we have, and I want to introduce this here as a separate option because this is a pattern that we have as well. A lot of options are just one single character, for example, A, R, and T, but there are also more available there. But we also have options that are consistent out of a word. Here, for example, --color, and this enables colorful output in case it's not enabled. Here in this case, for example, Ubuntu is configured in a way that by default it will show colors here. So this is enabled by default, but we could set it, we could put in equals here and set this, for example, to never to disable those colors. Let's just have a look at this. ls, we are right now in my home directory, --color equals never, and then we can see right now we have turned off those colors. On Ubuntu, by default, it will be set to auto, so ls figures out from where it's being called, and if it's called from a terminal, then it will enable colorful output. But here I have now specifically overwritten this default behavior by setting this color to never. Sometimes those longer options with 2 dashes and then a word can also be accessed by just one single letter. Here in this case, this color option, we need to write it like this, and we can either just write it like this without an equals behind, then we set it to the default value. If we enable the default, if we use -- color here would be auto. That means that ls will figure that out for us. Or I could here also just specify this and then I could set it manually. Here, the most important takeaway is that we do also have those additional options here that we do need to specify separately. So this means if we also wanted, for example, to add something like this here, to display all the files here and disable color, we would need to use those options individually, and then we would need to use those -- options here separately. We cannot combine them into something like what we've seen here. This doesn't work. We can only combine those single letters. Those longer words as an option, they always need a -- or a -- in front. The next thing that I want to emphasize is that we can also specify a path that we want to list. You remember in the lecture before, I said that our current working directory, the commands that we use, they will take this current working directory and do something with this. this is what this ls command is doing by default. By default, let's say here I was in my home directory and I would just execute this. It would display the contents of my home directory. But I'm also able to provide a path here. And in this case, what I use here as an argument will override the path that otherwise would have been provided by my current working directory, meaning this one here, for example, will now print out the whole contents of my root folder here of my Linux system. So as you can see, we are still here in our home directory. Our current working directory has not changed. But if we do provide an argument here, then it will take this as a path instead of our current working directory. This is common behavior that also applies to a lot of other utilities that we can use here on the command line. So I want to make sure that I really emphasize this. There's one more thing that I would like to make abundantly clear, and that's the distinction between relative paths that work on the basis of our current working directory and absolute paths that provide an absolute path to the file or folder that we want to work with. And this is what we'll talk about in the next lecture. Because we will be working a lot with files and their respective paths, I want to add, or I want to have this lecture here in this course that we dedicate to absolute versus relative paths. I know maybe if you've programmed already that you might have heard a little bit of this, but I really want to make this distinction here. Absolute paths start with a slash and they define the complete path to a file or to a folder. Thus, they work everywhere, no matter our current working directory. Just as an example, if my username was just Janus, this would always be my desktop. Or this would also always be my desktop. Why? If I say here, all the absolute paths start with a slash, why is this one here included in the example? The reason is if I use this in a bash, I don't want to talk too much about it yet, but bash takes this command, rewrites it a little bit so that it ends up with this absolute path before even the CD is being called. So here, if we go back and I wanted to move to my desktop or change my directory, I could say either this one here, and I could then navigate into my desktop, or I could type it also like this. And this would also be considered an absolute path because bash just like under the hood rewrites the command for me, and this will then be my home directory with the full path to my home directory, and then I navigate into my desktop here. So those paths work everywhere, no matter where I am. Then, however, we also have relative paths, and they are being resolved according to our current working directory. Just as an example, this one here would take from my current folder and go into the desktop folder, or this one would also start at my current working directory and go into the desktop folder, so they are exactly identical. However, this one here would go one level up and then go into the desktop folder. Let's also have a look at this. Here I'm already at my desktop, and if I would move, for example, one level up, I would then be in my home directory, and then I could be like, okay, here I want to now navigate into my documents folder. This is relative, because this path starts at my current working directory and works its way through, meaning we go one level up and then into the documents folder. Why is this important? Well, imagine, for example, I was in a different folder, let's say here, my root directory, and I would try to do something like this. And then we would find out that there's no such file or directory, that we are unable to navigate into this directory. The reason behind is that now, of course, this starts at my current working directory, which is now my root file system. And then, of course, this change directory command cannot be fulfilled. However, if I had provided an absolute path to this folder, for example, like this, then we can see it works from everywhere. We can always navigate here into that folder. Be really careful here, especially if you navigate into a different folder and then you just use the arrow keys, for example, to repeat a command that you executed before. The current working directory will still be the new current working directory. So if, for example, you would use the arrow keys, I have now typed it, but if I had now used the arrow keys to repeat a command like this, but in the meantime my current working directory has changed, then of course here this command will fail and we are unable to navigate into that folder. So this is the distinction here between relative paths that start on the basis of your current working directory versus absolute paths. Let's now have a look at how you can execute multiple commands one after another. And for this, you could, of course, just use enter and then type in the next command. But if you wanted to execute multiple commands at once, you can just add a semicolon in between them, and then the first command will be executed and then the second. You could end this with a semicolon here, but it would technically not be required. You can also just omit this. For example, here, this would now execute two commands here, one after another. Let's just have a look at this. Echo -n, hello, and a space, and then a semicolon, and then I say echo world. And now if I just hit enter, we can see here, this -n stands for that we do not want to print out a line break after the first echo. So this will just output hello and a white space. And then after that, we will just print out world. So let's have a look. This is now here, hello world, that has been printed here. Of course, we can also combine this or use this with other commands. So for example, I could say I want to navigate one folder up. Then I want to navigate into my desktop. And then I want to execute the ls command on my desktop then. And if I now hit enter, then we can see here, this one here has now changed to my desktop. And it then has outputted the contents of my desktop. The contents of my desktop, or the content there, just happens to be completely, there are no files there, so this is why this ls hasn't printed anything here. But we can now try this again. We could, for example, change into our root folder, then we could change into our home folder, that would be this folder here, for example, and then I could do an ls on that folder, and as you can see here, this one here has worked. We have now changed our directory here multiple times, and then we have outputted this, and this just shows how we can combine those commands. There's just one thing that I do feel like I should mention here. I don't like to combine commands that often. I mean, it might happen from time to time, but it's a little bit tricky here because one thing that I want to emphasize here, if I wanted to navigate, for example, onto my desktop and I'm in my user folder right now, I could just start typing desktop here and use tab to autocomplete to just conveniently navigate into my desktop. This autocompletion logic does not, it only takes into account my current working directory. And yes, this one will change my current working directory to my root file system, but it has not been executed yet. So for now, while I'm still typing here, my current working directory is my home directory, which means that I can get autocompletion here to complete the path to my desktop. But by the time, if I now hit enter, by the time this CD is executed, my my current working directory has changed to my root directory before already, and then I'm unable to navigate here into my desktop. So be really careful here if you really want to change the directory here. But for something like this, where we just change into a different folder and then just list the contents, and I don't need any tab autocompletion to write my command here, combining those commands can be quite useful. It's important that I do introduce this here because this might also be something that I use on slides every now and then. In this case, this means you can either execute those commands individually with an enter in between, or you could all put this into one line and execute them all at once. And this is how you can execute multiple commands at once. Let's now have a look at how you can get help. If some problems happen, how do you get help? How can you solve those problems? And for that, you can first try to use a --help or a -h. And for a lot of commands, this is implemented. We can just add a -h or --help or --help after that. And this will then usually show us a list of possible options and arguments and how we can use this program. Let's just have a look at this. Here, I would be on my CentOS, but it doesn't really matter. I can just say ls -h, and then we can see here for the ls command, this doesn't work. But I can use ls space --help, and then we can see here we do get some documentation, even the color here, it's being written, how we can use that, and we can scroll up here a little bit, and then we can see there are a lot of different options here. It may look a little bit congested here and difficult to read, but the reason is just that I have configured the font size to be so large that you can easily read it here in the video. But then, of course, the line breaks here, a lot of lines would only be one line if I had zoomed out a little bit. And if I zoom out a little bit here, then we can see it's actually quite a nice list, and this allows us to see how all of those options can work, or what options we got available here. We do not need to go through them. It's just a nice way, or this is just the way you can use to get help. Be aware, this is subject to the commands, so certain commands might implement that, certain commands might implement that properly, for example, on certain distributions on Linux, maybe on another there might be a slightly different version that's used, or sometimes, or actually sometimes this does happen. The ls command, for example, on a Mac would not display such a nice help menu as compared to the Linux version there. So be aware that there are differences between commands, and this is subject to the command. The next thing, this is also a little bit depends on the program, but we do have a special command to get help. This is man, and this allows us to check the built-in manuals. And for example, man space ls would print out a manual for the ls command. Important for this, the man pages or the so-called documentation must be installed on your system. Let's just have a look at this. I can say man ls here on my CentOS. And then we can see here, it prints out a manual that we can just read, and this usually also then here lists all of those entries. If we try the same on, or to quit this, by the way, we need to press Q. If we try the same on an Ubuntu though, and I would do man ls, then we can see here that it's complaining the system has been minimized by removing packages, and to restore contents, we need to run a specific command that's called unminimize. And then we also need to install a package here. The reason is that this is a desktop version of Ubuntu, and usually desktop users don't need those man pages. They don't use the command line that much, so it's okay if they are not included here. If we wanted to install them, we first need to run unminimize, this command, and then we need to install this man-db package. This unminimized package changes the configuration, for example, that those man pages get installed, and it will then also reinstall quite a bit of packages or software, because only when those packages are, or software tools are reinstalled, the man pages are then also installed. Before that, they were just thrown away. So I will now confirm this with a Y. We can see here it didn't work. We got a permission denied. We do need to add a sudo here in front. So the command would look the following: sudo unminimize. We will have a look at sudo here also later, pretty quickly actually. But for now, please just add a sudo here in front and then type in your normal username or your normal password for the normal user here on your Ubuntu system, and confirm this with enter. And now I will just confirm with a Y. Now we can see here it's doing something here. What's doing now, it's refreshing what updates are available and all of that stuff. And it's now offering to install all of this. So I will now just confirm this with a Y as well. And now I just need to wait until everything here has completed. Once this is done, it might tell us a few messages here. In this case, I will just confirm everything here with enter. There's nothing to do here. Just press enter whenever it asks you something, or answer everything with a yes if it asks you a yes/no question. Aside from that, we just need to wait until the install here has finished completely. Once it's done, we just need one more sudo apt install man-db. This will install those man pages on our system, that our manuals work. How we install software, we will have a look at this shortly. For now, just please execute this command, and then we will look into the details here later. This here now has worked already. It's already installed. Nothing needed to be done. After that, it's best practice to just reboot the system. We could do this here through the terminal, or I could also just go here into this menu, power off, log out, and then just press restart to restart my system. So now I'm just waiting a little bit until my system has booted again, and then I'm ready to use it. So now I'm back here and I've launched a terminal again, and now I can just say man ls, and as you can see here, I'm now also able to read those manuals here on my Ubuntu system. In case neither --help nor -h nor man works, you can also just try to find the online documentation for the corresponding tools, and otherwise communities such as, for example, Stack Overflow or Reddit's Linux communities can also be great for help. Be sure to then really search online for your issue. If it's something that's related to this course here, you can also, of course, ask a question in the question and answer area, and I'm sure other students can help you, or otherwise also we will try to do our best to answer as many questions there as possible. Just be aware it might take a few days. So this is how you can get help to specific Linux commands, how you can keep going then, and how you can approach problems like this. A quick interruption. If you want to learn more, this video here, it's just an excerpt of a 70+ hour long course about Linux. In this course, you will learn way more about Bash command line. For example, we will configure your terminal, or we will have a look at how colors work and everything like that. But you will also learn everything you need to know about Linux and how you can write Bash scripts, for example, a backup script. This course is super extensive because I decided to add so many different topics into this, so this is really the complete guide if you want to master Linux. In this course, you will also get quizzes, exercises, and a question and answer area. This is something that I cannot provide to you in this YouTube video here, unfortunately. So if you're interested, be sure to scroll down. I have provided a link for you there. However, let's now continue here with this video, and let's now get you started with using the terminal. Welcome to this chapter about file management. In this chapter, you will learn how you can create folders and also files in Bash. You will learn how you can copy and move files and also rename that. It's actually the same command than what we would also use for moving files. And you will learn how you can delete files, and especially how dangerous Bash can be and how you can mitigate that. This can prevent you from a lot of hassle because you know when you have to be really careful when you're using Bash. In addition, you will solve some real-world problems. So, for example, you will extract photos from a folder structure. That could be useful, for example, if you have an SD card and you want to extract all the photos from that one. And you will extract all excellent PDF files from a nested folder structure with a more specific matching there. So this chapter is really, really interesting, and you will learn everything you need to know about file management in Bash. So let's now get started, and let's start with our lectures. In this lecture, I want to introduce you to the important commands touch and mkdir. Let's have a look at how they work. So the first command is the touch command. This one allows you, or the typical use case for that one is that it allows us to create an empty file or even multiple files. Let's just have a look at how it works. So, for example, right now I'm in a folder here. I've navigated to that folder already with change directory with the cd command. And right now this folder here is completely empty. Let's say I want to create some letters because I want to invite my friends. Then I could just create those files for the invitations. So, for example, I could create one file here. And if I now list the contents of my folder, we can see that this file has been created here. Touch also allows us to create multiple files at the same time. So for example, here I could create multiple files, for example, like this. And if I now hit enter and I now list the contents, you can see that those two files have been created now. So as you can see here, the touch command allows us to create multiple files at the same time as well. But why is it called touch and not create if we are using it to create files? Well, the actual use case for touch is a little bit different. It still includes that we can create an empty file, and this is what we usually use touch for. But the actual use case for touch, what it actually does is that it modifies the timestamp of a file. So it checks whether the file exists, and if the file exists, its timestamp is updated to the current date. And otherwise, a new and empty file is created, of course, with the current timestamp. So let's see how we can check those timestamps. And luckily, this is built in already into the ls command. We just need to enable this output by adding a flag. So we say ls space and then minus and then lowercase l. And this tells the ls command that we are not just interested in the files, but also at the timestamps and additional information. We will have a look at all this additional information later in this course, but for now, this is listing our files. So as you can see, this is the time when I had created those files initially. Actually, it's not the creation date, but it's the last modified date that's being outputted here. However, in this case, it's the same because I've only created those files. But let's just see what touch actually does. So here you can see I'm touching this file again. And if I now hit enter and I now run ls minus lowercase l again, you can see that this timestamp here has been updated now, and it's now the current timestamp again, like 2 minutes later. So you can see that touch not just creates files, but also updates the timestamp. This was the first command. The next command is the mkdir command. This command allows you to create a new directory or a new folder. So let's have a look at how that one works. So let's say I'm in my folder here. I just enter clear here to clear my screen, and then I output the contents again. Let's say I want to create a folder because I want to collect everything that's ready, for example, because I want to print it. Then I could create a new folder with the name, for example, ready, and then I could hit enter, and now this folder has been created. If I now list the contents of my folder again, you can see here that we now have 3 files and this one folder. Well, we can't really see whether it's a file or a folder. On my system here, it's displayed in the same way. There are ways to get this into color. On some systems, it's in color by default. If we want to enable colors otherwise, we might have to add minus color here and then hit enter, and then we get a colorful output, and then we can see that this one here is a folder and those 3 here are files. Please note that depending on your terminal, it may also not work, but I would say 90% plus of the cases, this one should display colors. If it doesn't work, you might need to change the app you're using for your terminal and install and try out another one. But usually, again, it should work. All right, we were now able to create those files, and we were able to create this folder. But now, how could we, for example, move those files into that folder? And this is what we will look into in the next lecture. Let's now have a look at how we can move files and copy files. So the first command is the move command. That one allows you to move an existing file to another location, but you can also use it to rename an existing file, and it can even do both at once. Let's just have a look at how everything works. So I go back into my terminal, and let's say I'm here again in my folder. So we have a few invitations, and we want to move all of them into the ready folder. Let's start with the first one. So that would be that we want to move the andy.txt file into the ready folder. So I could just write this one, then I could hit enter, and now this file has been moved. And if I now output this, you can see this file is gone. I could now, that would be the one way, I could use change directory to change into my ready folder. And then I could list the contents of my ready folder. So right now I'm in my ready folder. If I now output the contents, we can see that the file is there. And I could now go back one level up again. So I'm back in my previous folder. You can see here, I'm back in my previous folder. So you can see we have now confirmed that we have actually moved that file. However, you've seen this was a bit tedious in the sense that we had to navigate into that folder, use this command, navigate back. So we needed quite a few commands just to look into our ready folder. The easier way would be that if I'm in one folder and I want to, for example, look into this folder here, I could just use ls with an argument, and I would just enter the folder name that I want to look into. So for example, here it would be the ready folder. This doesn't change my current folder. It just tells bash or the ls command that we don't want to look into our current folder, but that we want to look into this folder here. So we are now looking into the ready folder. We can see my file has moved, but I'm still at my previous folder. We can also confirm this, and this is the path, for example, of my current directory that I'm in right now. So you can see we have successfully moved one file. Let's have another look, and let's have a look at how we can move or how we can rename a file. So let me just clear my screen. So let's say here, for example, we've realized, okay, Max has a different name. For example, he could be called Maximilian, and we just made a mistake here. So let's correct this mistake. So I say move max.txt, and now I instead of moving that file into a folder, I can just provide a new file name. So for example, I could provide maximilian.txt, and now my file name has changed. So if I now list the contents here again, you can see that I've renamed that file. I could also do both, by the way. If I now realize, okay, I want to move the maximilian.txt file into my ready folder and rename it at the same time, for example, back to max.txt, I could also do this here with one command. So this one would take this file and move it into this folder, into this file. So this would be now a move and rename in one command. And if I now hit enter, we can see this file has moved into the ready folder. And if I now output my ready folder, you can see the file is called max again. All right, so this is how we can move files. Let's now have a look at how we can copy files. And for copying files, we can use the cp command, and this allows us to create a copy of a file. If we just want to copy a file, we can just use the cp command, as we've seen it with the move command before. But if we want to copy a whole folder, we must provide the option -R, so a whole folder is being copied. Why R? R stands for recursive, and this means that we want to go into the folder and copy the whole folder. Let's have a look at how that one works. So for example here, let's say we want to copy a file. So for example, the invitation to Laura, we want to copy, for example, because we want to invite one more person here. So I could just copy that invitation. And if I now output the contents of my directory, you can see that we have now just copied that file. Of course, we could also copy and rename at the same time. So for example, I could copy the laura.txt file into my ready folder. And for example, this would now copy that into that folder. But if I keep writing here, I could also provide a file name here. So for example, let's say I spelled that name incorrectly and I want to copy that file into that folder, and I want to have it provided as lauren.txt. Then I could say, or then I could enter this command. And now if I look into my ready folder, we can see that the laura.txt has been copied to ready/lauren.txt. So you can see how also with copying, we can do multiple things at the same time. Let's now also copy the eva.txt file into our ready folder. So I could just say eva.txt into my ready folder, and I hit enter, and we can see now if we look into our ready folder that those are the invitations that we have written. Now let's say we have all those invitations and we want to create a backup. So we want to copy the whole folder. If I now try to copy a folder, so for example here, I create a new folder, or I want to copy this folder to this folder, this one will be then created. It's, by the way, best practice to avoid white space in file names. They then usually bash. It's a little bit more difficult to address those file names. If I need a white space, I need to wrap everything in quotes, and it's a bit more tedious. So it's actually best practice to avoid those white spaces here in folder names. So that's why my folder is called ready_bug. So let's see, I want to copy my folder ready to that folder. If I now hit enter, we can see ready is a directory and it has not been copied. We can also see it has not even been created here. So the copy command or the cp command hasn't even touched or mkdir'd it. So let's see how we do that. I now need to repeat this command, and I need to add the flag -R. Luckily, I don't have to type everything again. I can use the arrow up key to navigate back to my previous command, and I can go through that list of my previous commands. So I go here, and then I use the left arrow key to navigate to the correct position, and I just add the flag -R. This tells the copy command that it should work recursively, so it should copy a whole folder. And now we can see that a whole folder has been copied, and we have a new folder here called ready_bug. So this is how you can move files and how you can copy files and also how you can copy directories. However, what happens if we want to delete files? So for example, let's say we want to delete our folder here, ready_back, because we no longer need the backup, or we want to delete this file because we have copied that into the ready folder already and we don't need the original anymore. How do we do this? And how you delete files and how you can delete folders and everything like that, we will look into in the next lecture. Let's now have a look at how you can delete files and folders. So if you want to delete a file, you can use the remove command, written rm, to remove a file or multiple files at once. For deleting a directory, we also need to pass in an option. That's here the option -r, and this tells the rm command that we want to recursively delete the folder. This then deletes empty and also non-empty directories. Let's have a look at how the rm command works. So let's say here I'm in my folder here, and let's say all my invitations that I had written in this chapter before, they have already been moved or copied into this folder here. So I don't need those invitations here anymore and I want to remove them. How do I do this? I can use the rm command to delete this file here, for example, or I can use also the rm command to delete multiple files at once by just providing multiple file names here. And now those two files will be deleted with just one command. If I now hit enter, we can see here everything has worked properly and those files have been removed. We need to be really careful here. This rm command is extremely dangerous. Let me show you an example. So for example, on my desktop, I just now navigate to my desktop and then I have a folder there called presentation. So this one here stands for my home folder. Then I go into my desktop folder and then there I go into my presentation folder. And if I would now, for example, list the contents, we can see that we got some PowerPoint slides here. If I now, for example, would delete this PowerPoint slides with the rm command, I would just hit enter. Now this presentation is gone. Oops, this was the slides from my presentation. No worries. Let's look at how we can restore them. So I just opened my bin and we can see, or as we can see nothing. This is because this rm command has actually deleted this file permanently. So I'm very sorry to tell you that there will no longer be any slides here in this course. No, don't worry, I got a backup. This was intentional here. But please be really careful when you use the rm command, because this will permanently delete those files, usually without any confirmation, depending on your configuration. So this is extremely dangerous and you really need to be careful here. This then also explains the behavior, why we need some special parameters to be allowed to remove a folder. Let me go back to my previous folder that was placed on my desktop. And then in the folder called Folder Management, I use tab to just autocomplete all those paths, so I don't need to type everything completely myself. I move back, or I change my directory to that folder, and then we can see I'm now back in my folder here with the files we had worked with previously. I enter clear to just clear my screen here. So now we have a folder, or we are in a folder where we have this folder and we have those backups here. If I try to remove a folder here, for example, the ready_bug folder, then we can see that the rm command will not delete it because it's a directory. This is because the rm, as we've seen before, can be really dangerous and permanently delete our files. And it's worse if it's deleting just a few files, but it's even worse if it would just remove all the folders in the folder structure. So this is why we need to enable that rm can actually delete folders. So here in this case, for example, we could say rm minus, and then we provide the flag r here. And this tells the rm command that we want to this to be applied recursively. So now this folder was deleted, and we can see here all those or all my backup is gone now, and we only have this one ready folder here. this gives us a nice reason to look into another command. The other command is the mkdir command. This stands for remove directory, and it only deletes empty directories. You can imagine that this can be really, really useful because it might prevent some serious data loss. So whenever you try to delete an empty folder, please use this command. Let's see why. So for example here, let's say we have this ready folder, but there are files inside. So we can see this if we list the contents of that folder. There are quite a few files inside and we really want to keep them. Let's say we would try to remove this one, then we would see here it's a directory, and if I would now, for example, accidentally type in this one, it would permanently delete all my invitations. And right now I've already deleted my backup, so this would actually be serious data loss if I would execute this command. However, this command here is way safer. If there are files in that folder, it will just tell us that this directory is not empty, but it will not actually delete this directory. So you can imagine this can prevent serious data loss. I want to tell you about a few caveats though. So imagine we have a folder here. Let's call it, for example, images, mkdir images. And we have a file in that folder. So for example, we have a file in our images folder. I use the touch command and I tell touch, in our images folder, I want to create a file. So for example, I want to create a file that should be hidden. So the file name starts with a dot and I call that file thumbs.db. Then this file will not be created in my current folder, but in the images folder, and this is the file name, and because it starts with a dot, it's a hidden file. So I just create that one. And if I now list the images folder, we can see that it looks that it's empty because by default, it doesn't show hidden files. However, mkdir will not delete that folder because of course it's not hidden because there's a hidden file in that images folder. If I want to list the hidden files as well, I can use ls-a, and then we can see that there's actually this .thumbs.db file in my images folder. So just be wary, or just be aware that if there are hidden files in a folder, they also count as files, and mkdir will then not work on that one. By the way, the other output here, this is the dot just stands for the current directory. So this would stand for the images directory because we've printed that one, and this one would stand that we want to go one level up. But those are not actually folders. It's just something that ls-a prints. This is the only file in our folder images that exists here. So just be aware that whenever you use mkdir, the folder must be completely empty, including empty of hidden files. So how could we work right now? The way to go would be, for example, I would first delete the thumbs.db file, and then I could use the mkdir command to delete the images folder. And now you can see that I've combined those two to delete it, and this would be a little bit safer than the rm-r because it's more verbose, or it's more explicit in a sense that we really declare which files we want to delete or which directories we want to be removed. All right, this is how you delete files. A quick interruption. If you want to learn more, this video here, it's just an excerpt of a 70+ hour long course about Linux. In this course, you will learn way more about bash command line. For example, we will configure your terminal, or we will have a look at how colors work and everything like that. But you will also learn everything you need to know about Linux and how you can write bash scripts, for example, a backup script. This course is super extensive because I decided to add so many different topics into this, so this is really the complete guide if you want to master Linux. In this course, you will also get quizzes, exercises, and a question and answer area. This is something that I cannot provide to you in this YouTube video here, unfortunately. So if you're interested, be sure to scroll down. I have provided a link for you there. However, let's now continue here with this video, and let's now get you started with using the terminal. In this lecture, we are now ready to talk about the file name expansion, or the so-called globbing in bash. This is an example. You will learn more about the power of bash during this course, but this is an example about the power of bash and why bash is so incredibly compact but still incredibly powerful. So let's just have a look at how this works. So the file name expansion is the process in which Bash rewrites our commands before they are even executed. Globbing recognizes and expands predefined wildcard characters. We can imagine those wildcard characters as a way to enable us to search for specific patterns. And it will then search for files that match this pattern and expand this command. Expanding is just another word for rewriting our command. This allows us to easily access multiple files. Let's have a look at how this works. So here I'm in my terminal, and in this case we are in a folder where we have a few images, but we also have a movie and some additional information about that movie. Let's say we want to access all those images and move them to a folder. So I could, for example, create a new folder here that I call images. And now I would want to move all those images into my images folder. I could do this by using the move command. And the move command actually supports that we are able to move multiple files at the same time. It works like this, that we first specify all the files that we want to be moved. So I just specify all those files. My shell or my terminal here supports that I do copy and paste with keyboard shortcuts. This might be different depending on the shell you might use. Maybe you have to type it manually. So for example, here I could say, okay, I want to move all those files, for example, into my images folder. And I just hit tab to autocomplete that one. And then I hit enter. And now all of those 3 files have been moved. If I now would look into my current folder, you can see that those images are gone. And if I now look into my images folder, you can see that those images are in that folder. You can see this works, but we had to specify this for all of those files individually. Also, the command now to move everything back is also really long. So for example, here I would have to list all my images individually. Right now I'm still in my parent folder, so I have to specify the path here to all of my images here. Then I say that I want to move them back into my current folder. So the last parameter here is my current folder, and this tells the move command that all of those files that I specified before should be moved to this folder. If I now hit enter, we can see all those images are back in my original folder. This was the process without globbing. Now we want to use globbing to simplify this. Let's have a look at that. We first need a wildcard character. And the first wildcard character that I want to introduce you to is the star or the asterisk sign. This allows us to match 0 to any number of characters in a file or in a path. And Bash will expand this command in that case, or rewrite the command for us. Let's just have a look at that. So, how can we access all the images and move them into our images folder? I could say move from my current directory everything that starts, like I want to match 0 to any number of characters in our file name, but at the end it should be written .jpg. And I want to move that into my images folder. And then I can just hit enter, and now I have moved all of my 3 files. Imagine if that folder would contain 100 files, it would be almost impossible to list all of those files manually. However, this one move command would have done all of that for us. So this just shows how incredibly efficient Bash is. But it's better to check on Bash or on what actually happened. So you can see here, those images have actually been moved into our images folder. Of course, we can also use this wildcard character, for example, in something like this. We want those images to be in my images folder, and then we want to access all the files there, and we want to move them back to my current folder. Here, you can see that I use this one to match the whole file name, but of course I could also say that at some point there should be a dot, and then there should be 0 to any number of characters here again, or that the extension should be JPEG. So whatever I use here, this will move all the files from this folder back to here, my current folder. Except, by the way, hidden files. This one here by default does not match hidden files. Hidden files I would need to access like this. But this would move all the files that are in the images folder back to my current folder. We can see now that those images are now back again in my previous folder. Why did I move them back? Well, at the end I want those images, of course, to be in the images folder, but I moved them back because I want to show you something really, really important. This happens before bash is executing the command. Why is this so important? This is important because this works with all the commands that we can use in bash. So, for example, I could also use the echo command, for example, and provide this one here. And then bash sees, okay, there's an asterisk sign here. Let's just expand or rewrite the command. And we can see here, this has been rewritten to our parameters, or to this one, what you're seeing here right now. And this has just been outputted. So as you can see here, this one has nothing to do with our move commands or with our copy commands or anything like this. It's a shell feature that happens before our command is being executed, and in this case it just expands to all of those files. So to put it in other words, our move command doesn't even know that we've been using globbing here, because our shell, our bash, is rewriting the command to provide all the individual file names here, and it's expanding it. This just means it's rewriting it, and then we are moving all of those images into our actual images folder. And as you can see here now, this has now worked. All the images are now in the images folder. If globbing fails, so in a sense, for example, there are no images here. So if I would now try to move this JPEG to the images folder, and this globbing fails, in that case, bash will not process this globbing, and the move command will understand this as if it was a file name. So it will understand, okay, *sign.jpg as a file name, kinda, and it will tell move to move that file to the images folder. But you can see here, this one now could not work because a file with this file name, of course, doesn't exist. So move is now complaining that it could not move this file. So if globbing fails, in that case, if we are using a bash, then this will just be the file name, and it will be understood as a normal file name. So if it can, if bash can find images, then it's perfect. This will be expanded and rewritten. And if it can't find anything here that would match that one, it will just pass what we have typed here before to our actual program. Be aware if you're using other shells, I don't want to go too much into the details here, but this one, for example, would work different in a ZSH shell. If I would run the same command in a ZSH shell, even though those two shells are quite similar, bash and ZSH, this would be an example where the command would be a little bit different. I personally, by the way, prefer the way ZSH is set up here, in a sense that the ZSH will then just complain that globbing could not be applied, and it will not even call the move command with this here as a file name. So I personally prefer what the ZSH is doing, but this is just an example about the differences between those shells. Luckily, the differences between bash and ZSH are quite minor, so I'm able to point those minor differences out here during the course of this course. I now just enter exit to go back into my bash, and yeah, this is now pretty much how globbing works. I want to end this lecture with a few important hints. Globbing, or file name expansion, uses wildcat characters, and they must not be quoted. So neither in single quotes nor double quotes. If they are quoted in any way, so for example, if I would say something like this would probably the way to go if we use an echo. This is also one of the reasons why we were also always using single quotes, because they pretty much disable all the rewriting features that the bash might apply. File name expansion or globbing is just one of those. Then we can see that globbing is not even applied here. Well, okay, right now there's no image in that folder, so bash would not apply the globbing anyway because it couldn't find any pictures. But if I would do something like this, you can see this one here, it's now not being rewritten, but if I leave out those quotations, or the quotation marks, you can see that this one here has now been expanded to all the files and folders in my current working directory. So you can see the difference here. This one is just a string and it will not be changed. This one here will have globbing or file name expansions applied to. Why is it important that we can disable globbing sometimes? Well, let's say we want the file name of a file to be star.jpg. So we want the file name to be something like this, for example. And then I could just touch this file and I could put it into those single quotes here. And then globbing would not be applied to this one here. And if I would now output this, you could see that this one here is now an actual file name. If I now want to do something with that file, I should disable globbing again, of course. So for example, if I want to move that file, the easiest way would be to, for example, put it into single quotes, and then I could, for example, rename it new.jpg or something like this. And here I've now disabled globbing again. So this is now just considered as a file name with a star inside or asterisk. And this file is now moved to this file here if I execute it, and now you can see how this one here has been executed. This one here might have worked also with globbing, because technically then this one here would have resolved to the file name star.jpg, because there's only one .jpg file in that folder, and that would then also have been renamed. So here in this case, both would have worked, because even if globbing would have been applied here, it would still have found this file here. But if we want to disable globbing, this would be one of the ways to do it. We will have a separate chapter about the so-called bash expansions and globbing and how all of this works, where we will look more into the details here. But for now, it's more important that we get a better overview about what bashes can do, because only then we will be able to actually utilize the full potential of the so-called shell expansions and globbing and how all of that relates together. So for now, we will just have a basic overview here, and later we will look into all those details. The next thing I want to tell you is we haven't looked into regular expressions. We will have a separate chapter about them later in this course. But because I know that this course will be watched by quite a few programmers, or people who have programming experience before, and you may have used regular expressions before, I just want to point out that globbing does not use regular expressions. It looks a little bit the same, that we have wildcard characters and stuff like this, but it's not regular expressions. It's a different syntax. So please do not confuse it with regular expressions. It's something completely different from a syntactical level. So just be aware of that. So these are the basics about globbing. However, globbing also supports a few more wildcard characters, and I want to introduce you to them in the next lecture. In this lecture, I want to show you additional wildcards that you can use for globbing. So, for example, we could use the single question mark to match any single character. So we had the asterisk sign that would match 0 to unlimited number of characters. However, the question mark only matches exactly one single character. We can also specify ranges using the square brackets, and then we define the range. So for example, here we would specify one character out of the range of all numbers. So that would mean we would exactly look for one digit here. Let's just have a look at those two first. So, for example, here you can see that I'm in a folder, and for example, here we have those two different files. How could I match those, for example, using the additional tools? So one thing I could do, I use the echo command here because I don't want to move those files for now. So I could say, okay, my file names, they start with EM or IMG. Then I would want, for example, one character, that could be anything. And then I want those file names to end with 6677. And then I could say that I would accept every file extension here. If we can see, this globbing has still worked and it has found those two files. The advantage is, for example, if one of those files would be called slightly different, for example, this file here would have a slightly different file name, for example, something like this, and then maybe I just add a letter now. if we had those two file names here, for example, one with an underscore here and one with an A here, if I now go back to my previous command, this one here would still match both of them because this one accepts exactly one character here. So you can see here, this one here has now not found this one here because I had written it in the wrong way. The file name is wrong. It needs to be like this. I had forgotten 17 here. So I just repeat my echo here again, and now you can see that it finds the movie and the SRT file, so you can see how the question mark here works. Let's have a look at how the numbers or how the square brackets work. So for example, let's look into our images folder, and you can see here that we have different files here. Let's say we want to find those two images, the images that starts with a 6 here, and then we want to have exactly 3, for example, digits here. Then I could say echo, and I want to go into my images folder. I could either say images / or I could indicate that it starts at my current folder. This one here is a little bit more verbose. And then I could say, okay, it should start with img. Then I could say here character, then I say, okay, it should continue with a 6. And then I use the character range here, for example, like this, to indicate that it should be followed by exactly 3 digits. Then I would have a dot, and then, for example, I want all the extension to be to contain exactly 3 lowercase characters. So I've typed those character ranges in here. I'm repeating myself here because I want to have 3 of those lowercase letters. It does not, like the normal globbing does not support that we can just say here, this should be repeated 3 times. There's a feature called extended globbing that does support that. But the normal globbing does not support that we can say here something should repeat a few times. So we need to repeat it ourselves. So if I now hit enter, you can see how those 2 images have been found. However, the first image has not been found. One thing why we are not going into the detail here about how we could use extended globbing and all of that stuff is because I have almost never used this one. Like this one here I have used in practice, but if I'm completely honest, I actually use the asterisk most often. So if I would just if I would want to find all those images that start with this one, I would usually write it like this, images /img _6 and then just the asterisk sign, and then I would also find those images. So as you can see, there are multiple ways to find our files with globbing, and you can really pick whatever works best for you in your current use case. But this is something I want to show you, but everything more than that we are going to leave out of this course. I want to show you one more thing, how you can use globbing. That's the double asterisk sign. This matches 0 up to arbitrarily many characters, including the /. So it looks into the subfolders. However, please note, it's only supported in Bash 4.0 or higher, and it might be necessary to enable this through the sh-opt command -s glob star, and we might have to enable that feature. Let's just have a look whether this works in my terminal. So right now you can see here, I'm in my terminal, and let's say I want to find all the JPEGs. But as you can see, the JPEGs, they are in my images folder here. So how do I find them in my nested folder structure? The way to go is that I use the glob star, and the glob star I usually combine with a / and then the actual file name that I want to use. This is important because otherwise, if I would add something or if I would write it like this, it would look for a folder that would be called images.jpg, and this is not what we want. We want to have 0 to unlimited number of folders in between, and then we are looking for files that match exactly this pattern. So this is why we use glob star, then a /, and then how we want those files that we actually look for, how they should be formatted. If I now hit enter, we can see here it's expanding because sh-opt was enabled on my computer here. So as you can see, this can be really, really useful if you want to find all the files in a specific folder structure. And of course, you could combine it now. For example, you could now copy all of those files into, for example, the current folder, so you could really combine it. Or you could also look for multiple file types. So for example, something like this would copy the JPEGs and all the .mov file with lowercase file ending into my current folder, for example. So this would expand, this one here would expand, and this here would then be the destination where we want to copy everything to. So as you can see, one command here in Bash can be extremely powerful and can do a lot of stuff at the same time. And this is why why I like Bash so much, because we have so much power in just one simple command. However, we need to be a little bit careful with globbing, and I will show you that in the next lecture. A quick interruption. If you want to learn more, this video here, it's just an excerpt of a 70+ hour long course about Linux. In this course, you will learn way more about Bash command line. For example, we will configure your terminal, or we will have a look at how colors work and everything like that. But you will also learn everything you need to know about Linux and how you can write Bash scripts, for example, a backup script. This course is super extensive because I decided to add so many different topics into this, so this is really the complete guide if you want to master Linux. In this course, you will also get quizzes, exercises, and a question and answer area. This is something that I cannot provide to you in this YouTube video here, unfortunately. So if you're interested, be sure to scroll down. I have provided a link for you there. However, let's now continue here with this video, and let's now get you started with using the terminal. In this lecture, I want to emphasize that you have to be really careful when you use globbing. The problem with globbing is that it's quite broad, and this can lead to some issues sometimes, or it can actually be dangerous sometimes. I use the word dangerous here because if we use globbing in a wrong way, it can lead to permanent data loss. So if we combine it with the rm command, for example. The problem is that Bash doesn't differentiate between a folder and a parameter. So that's exactly the same thing for the Bash. It doesn't differentiate between. So it means that the name of a file may be interpreted as a parameter. This is especially dangerous if a file has a name, for example, such as -rf. That's a totally valid file name. But then, for example, if we would execute rm asterisk in that folder, then we can see that the star sign, it's expanded. So -rf will appear in the command, and then the rm program will think that -rf is a parameter, and -r means that it's recursive, -f means that we do not want to ask. Sometimes rm might actually ask us, depending on the configuration, whether we actually want to delete a file, but even if it would be configured in a way that it would ask us, it means that we want to suppress that and we don't want to be asked at all. And then it means that everything will be deleted recursively. Let's just have a look at how all of that works in our shell. So I'm here in a new folder, and I just want to create a few files. So for example, here I create one file called important.txt. And another one I could, for example, create, for example, here, letter.txt. So you can see that here are a few important files. Then maybe we also have some documents. So I create a documents folder, and in that folder, I also create one file now, for example, here, what do I create here? For example, presentation.txt. So as you can see, we now have here a documents folder, and we have two documents here and another document inside that folder. So you can see this is a normal file structure that we might have. Now, if I use this sign here, Bash will just expand this for me. So this means that this is now being expanded before our command is being executed, and it just means that all of this stuff is passed as a parameter to our echo program. It's no problem in this case, it can just output that one. The same would happen if I would do this one here, then it would also calculate all of this expansion, would be calculated, it would be set here, and the RM program would run and like it would remove the files, but not my folder because the -r flag is missing. I don't want to execute this program right now. However, the problems start happening if we have a file that would be called, for example, -rf. Just as an example, we could also have a file called -r and another one -f, but let's put both into one file. So we create a file -rf. You can see that I'm using the single quotes here. However, the single quotes in Bash, they don't have that much of a specific meaning. They only have the meaning whether, for example, the globbing should be applied or not. So this is actually, well, it's a valid file name, but Bash understands it as a parameter for our touch command, at least this part of what I'm highlighting here. And it's trying to think that we want to create a file called f, and somehow it can't even create that. So maybe this one here has even changed the behavior of our touch command. How or what this parameter does in this case doesn't really matter. All what that matters is that touch doesn't understand this as a file name. There's no differentiation between a parameter and a file name in Bash that we use as an argument. So here, this is understood as a parameter that should modify the behavior of touch, and this one then, of course, doesn't work. To get rid of that behavior, here actually we would not necessarily need those single quotes, but we can add the hint that it should be in our current folder with the // here. And then for touch, it's clear that this is not a parameter that should change the behavior of touch, but that this should refer to a file that's in our current working directory and that we want to create this file. Now you can see that we have created a file with a file name -rf. What's now the problem? Let me do this one here first. If I now just use the asterisk here, and the file name expansion is being applied here, you can see all of those, or this is the result of the file name expansion. If I would now call rm with all of those parameters, again, Bash is just rewriting the command for us before it's even executing our command. So what I'm highlighting here, this one will be replaced with all of this one. And this one will no longer be a file name, but a parameter, because this is how rm will see this file. And if I now hit enter, you can see it has not asked, but it has deleted all the files and folders, and my important documents got lost. So you can see that the rm command now has not worked the way we thought it would, because this one file name here has changed the behavior of our rm command to, for example, include directories. And even if our system was configured in a way that it would ask, that it would not ask us before it deletes. So everything has been deleted, at least all of those documents here, or this folder and those two documents that were listed here. This file here, of course, has not been deleted because rm has understood this as a parameter that should change the behavior of rm. This is why this file is still here. You can see that this can be really, really dangerous, and we might accidentally delete files that we don't want to delete. Let me just create a few files here again. So how do we protect us from that? The way to go is that we use a slightly different way whenever we use the asterisk sign. And it's actually better to always try to write it in that way. The way to go is that we add a / here, which just means that we want to go into our current folder, into our current working directory, and we want to list all the files here. Look at what this expansion does differently than before. Let me show you before. It was expanding to this one, but if I would use this one here, our paths are slightly different. You can see that they all start with a /. And this means, for example, for our rm command, that this is no longer a parameter, but this is actually a file name that it should delete. So if I would now say rm./*, this file name cannot be parsed as a parameter, so it will not change the behavior of our rm command, but it will be parsed as an actual file that we want to delete. So if I now hit enter, again, it has just deleted everything here, but if there was now a directory or whatever, it would have asked us whether we actually want to delete this directory. We can see this, for example, here. Let me just create a directory again, documents and touch letter.txt touch -rf. So now we have all of those files again, And now, for example, if I would do this, the documents folder will not be deleted because the -r flag is not active, because this one here has now been understood as a file name because we have added a // before. So this is best practice, that whenever you are dealing with files that are in the current folder, that you just add this one here before, because every now and then it might prevent a lot of problems, and it will make sure that your program or your script or whatever you type here will always act in a really, really predictable way. And then this feature is really, really powerful. Don't get me wrong, this is not necessarily bad. This is just the way Bash works. And it kind of makes Bash so extremely powerful, all of those features. But with great power comes great responsibility. So we need to be aware of all of this stuff. And this is why what I really also try to emphasize here in this course. On the one hand, I try to show you how powerful Bash is and how much you can do with just a line or two of code. But then I also want to point out, okay, these are the things that you need to pay attention to. And this, for example, is one of them. All right, this is what you need to pay attention to when it comes to globbing or file name expansion. A quick interruption. If you want to learn more, this video here, it's just an excerpt of a 70+ hour long course about Linux. In this course, you will learn way more about Bash command line. For example, we will configure your terminal, or we will have a look at how colors work and everything like that. But you will also learn everything you need to know about Linux and how you can write Bash scripts, for example, a backup script. This course is super extensive because I decided to add so many different topics into this, so this is really the complete guide if you want to master Linux. In this course, you will also get quizzes, exercises, and a question and answer area. This is something that I cannot provide to you in this YouTube video here, unfortunately. So if you're interested, be sure to scroll down. I have provided a link for you there. However, let's now continue here with this video, and let's now get you started with using the terminal. In this chapter, we want to continue our journey with file management, because we have now already seen how we can in general manage files, but in this chapter we want to focus a little bit on text files. So it's kind of like a separate chapter, but it's kind of like part 2 of the chapter about file management. So in this chapter, we will learn how to work with text files, and this will, for example, mean that we will explore different commands to print text files to the terminal. Because let's say, for example, you have a long log file, maybe 10,000 lines, maybe 100,000 lines, then maybe you don't want to print the whole log file to the terminal, but only the start or only the end. And this is why we will explore different commands in order to do this there. So we will explore that. Then we will also see how you can calculate the size of a file, count the number of lines in that one. So this allows you to get like an impression of a text file. We will then also have a look at how you can edit text files in the terminal. Why, if we have a graphical user interface? Well, maybe we don't have. Maybe in the future you will be connecting to a server and you will only have a terminal or only a shell there, and then you still want to edit configuration files or text files. So this is actually quite essential, especially if you will be working on Linux systems that do not have a graphical user interface or you do not have access to that one. So we will see how we can edit text files in the terminal with Nano. That's like a simple text editor there. Last but not least, we will then finish this chapter with a quick exercise about how to work with files, so you will also, or you can also practice then your knowledge immediately. So let's now just get started. In this lecture, I want to show you how you can read files with the command line. The easiest way to read files is the cat command. This just prints out the contents of a file. For example, we could just say cat data.txt, and then this command would read the data from that text file and print it to our terminal. Let's just have a look at how this works. For example, imagine I'm here in a folder and there's a file called bash.txt in that folder. Let's say I want to output this file directly to the command line. Then I could use the command cat, put in a space, and then as a parameter I just pass in the file name, for example bash.txt, and then I hit enter, and then we can see the contents of that file. Here, be aware that we can use all the bash features we have learned before. So for example, I could also use globbing and let bash calculate the file name for me, and we can see that this file is now also being outputted. In case this would match to multiple files, all of those files would be printed to the terminal. The cut command, there's one nuance that I want to show you. I frequently have problems if I accidentally cut binary data. Let's say, for example, I would accidentally cut a JPEG file. Of course, we can't print this JPEG onto our terminal. Well, actually we can. We can see all the binary data that is being displayed here. I frequently had the problem that after cutting binary data, that after that my terminal doesn't work properly anymore. Right now, here this terminal seems to be relatively reliable, but some of the terminals do not work the same way before. It seems to be me that maybe in those binary data there might be special commands that are interpreted by our terminal, and they change the behavior of our terminal in unpredictable ways. Thus, I would highly recommend you that if you do experience problems in your terminal after having cutted binary data, it's probably because special commands are being sent to your terminal, and the terminal is doing something that it shouldn't be doing, and it may act in a weird way. After that, you might have to restart your terminal, and then everything should work. However, the cut command is not enough to display files here in our terminal. Why? For example, if we look at the folder here, and I've provided you this folder as a download, so you can also reproduce exactly the same as I'm doing here. We see that there's this text file, romeo.txt. And this text file contains the whole ebook, Romeo and Juliet. Luckily, it's public domain, so I'm able to use it in this course. If I just try to cut this file, everything will work. However, this ebook is about 5,500 or even a little bit more lines long, so I might have to scroll quite a bit up in order to be able to see the whole book. And the terminal that I'm using here, they all have to buffer the previous lines. And depending on the configuration of my terminal, I may or may not be able to see all the lines of this book. Let's see how far I can scroll up here, and then we see I can't even scroll up enough to see the whole book. This is because there's a buffer of the last lines that have been outputted by our shell. And if this buffer is exceeded, the first lines of our file are lost and we can't read them. So in my case, I'm not even able to read the whole book with the cut command. This is just because the file is way too long and it doesn't fit into the buffer. Of course, I could try to see if my terminal offers any settings, and maybe I could increase this buffer, but at some point this will also slow down our terminal. Isn't there a better way to work with larger files? And there are. And one command is the head command. This allows us to show us the start of a text file. We can also specify the parameter -n to show for the number of lines. In addition, we can use the tail command to show us the end of a file. Let's see how this works. Let's say I have a really long book, the romeo.txt, and I just want to output the first 10 lines. Then I could use the head command with this parameter to just output the first 10 lines. And if I now hit enter, then we see, okay, we're still not in the book yet. We are still at the license declaration and all that stuff. But at some point the book would start, but the head command, it just outputs the first few lines of our text file. If we do not specify any parameters here, then by default it actually prints out exactly 10 lines. But there's not just the head command, there's also the tail command, and this allows us to output the end of a book. So here in this case, this is the end of the book, and well, in this text file, we can see it's still another license declaration, but this is the end of our text file that is now being outputted here. As you can see, this might be really, really useful if we work with like long files. However, we weren't actually able to read the book. So isn't there a way to actually read those large text files? And luckily there is, but I want to present you that in the next lecture. Let's now have a look at how we can read large files using the less command. The less command, or the less program, allows us to read large files, and it allows us to not run into the same problems as with the cat program. When we open a file with less, we can use the arrow keys to then navigate through the file, or we can use special keys such as F for forward or B for backward to navigate a whole page ahead or back. Let's just have a look at how this works. So, imagine I want to read the whole Romeo and Juliet book on my command line, or it would be a long log file if I'm the admin of a web server. But in my case, I want to entertain myself and read the book. So, I can say less romeo.txt and just press enter, and now I'm able to read the book. And the nice thing is I can now just use the arrow keys to actually scroll through the book, and now you can see that I'm now actually starting to get to the prologue. Actually, no, I'm still in the table of contents, but I'm actually able to read the book and to go through. I'm using the arrow keys to go through the book here. However, if I want to go a full page ahead, I can press the F key and it will jump a whole page ahead. And this can be useful because then I don't need to scroll through the book, and every time I reach the end, I can just press F and continue reading from over here. As you can see, I'm thus able to read the book quite comfortably. If I know, okay, I've already read about half of the book and I want to navigate to a percentage of our content, I can just enter 50p and navigate, for example, to 50% of our content. Let's have a look. Here, I can just enter 50p, and then we see that it has scrolled to 50% of our book, and this is right now exactly the middle here of our book. However, can you trust me? How do I know this? Well, there's another command with less, and we can use the equal sign to show info about our current position. So let me just go back and I press equal, and then we see here this is our current position, and right now we are exactly at 50%. To hide this again, we can just press enter and we are back in our reading mode. There are more options here for less. Another option would, for example, be minus uppercase N, and this would tell less that we want to display row numbers. So let's try this out. So here I just type in minus big N or uppercase N, and then I confirm this with enter. And now we can see that when I scroll through the book, we can see the row numbers here, and this can give us some orientation where we are in our book. If we want to find something in this book, then we have also the ability to search. We can do a forward search with a slash, or we can do a backwards search with a question mark. Forward search means starting from our current position, let's find something. Backward search means let's find something that's before our current position. For example, let's say I'm looking for the word important here in this book, and then we see, okay, here we are. I guess we are back in some legal paragraphs, but at least we found the book, at least we found the word. Or I can try a backward search for important, and then we see, okay, there was this one, and before that one, there's no other occurrence of important here in this book. Okay, let's search for something else, for example, food, and then we find here the word food in line 4846. As you can see, this might be quite useful, and we can go through our book here. If we want to quit, then we can just hit the Q key, and then less will quit itself. So if I now go back and I just hit the Q key, then we can see less has quitted itself. As you can see, the less command may be quite useful for long files. It supports way more that I've shown you here in this lecture, but I would say I've shown you the most important features of less, but yeah, there are way more. But you can imagine it can be quite useful if you do work with long text files through a command line. When we cut a big file or we output that to the terminal, it can kind of overwhelm our terminal, or it can take quite long. So let's now have a look at how you can get the size of a file before doing that. And one way is that we can use the word count program. That's the WC program. And there we could just say, okay, word count space file.txt, and then word count would open the file and tell us some information about it. This command would then print out the number of lines, the number of words, and the number of bytes of our file. We can see that we have two ways of writing that. We can say wc file.txt, or we can specify a few parameters, which would be here in this case lwc, to be a bit more specific about what we are looking for. The thing is that word count supports various parameters. One, for example, would be -l, that would just count the number of lines. Or we could also use -w, which would count the number of words, or -c, which would count the number of bytes. It's -c because C stands for character. Back in the days, one character used to be usually 8-bit long, 1 byte. Nowadays, characters can be way more complex. We have emojis and all of that kind of stuff. But the flag is still called -c because back in the days, it used to stand for 1 character. So those flags allow us to specify what we are looking for, but if we leave it out, then it will print the number of lines, the number of words, and the number of bytes. By the way, depending on your system, there may also be more flags that you could use, but those are the 3 most important ones and the ones that should work on any Unix system. Let's now have a look at how we can use the word count program. So, for example, let's say we are in a folder, and here we have the book Romeo and Juliet. Let's find out what word count tells us about this book. Please note, WC, it's a program, it's not a bash feature. It may be that you might have to install this, depending on how you use or where you use the bash, but usually this is one of the default programs, and it should usually exist on all computers or on all Unix systems. So, if I just invoke the program word count, and I pass in the file that I want to access, for example, romeo.txt, then we can see, okay, this file contains 5,600 something lines. This is the number of words, and this is the number of bytes that this file contains. One common parameter is that we want to specify which thing of those are we interested in. And the most common way would be -l, which means that we are only interested in the number of lines. I could now say romeo.txt, and we see it only outputs the number of lines. Technically, there are also other parameters. For example, I could also just output the number of bytes, but the most common way to use this is -l for the number of lines. As we can see, we are able to inspect this file and see ahead, okay, maybe this is a large file, and we should not cut this into our terminal directly, but it would be better to use less for this one. However, there's also another way to see whether a file is big or not, and we can do this with the program disk usage, or DU, or actually just DU. That's the program name, and the program name DU stands for disk usage. This will calculate the size of all items in this folder, or we can also pass in a file name as a parameter, and then it will only get the disk usage for that one file. We can also specify the parameter -s to just get a summary. Otherwise, disk usage will tell us the size of each folder that exists in our current working directory. So if we have subfolders there, then it will tell us the size of each of those subfolders. Let's have a look how it works. So I'm here in this folder. There's no subfolder here. I can just start the DU program by just starting it, and it uses my current working directory, and then we can see how big my current working directory is. I could also specify a file. For example, I could say, okay, I'm only interested in the disk usage of romeo.txt, and then we get the size, which is here 336. What does this 336 mean? Well, it depends. It means the file size of this file is 336 unit. How big is a unit? That depends on the operating system. There's one configuration option that one unit is 1024 bytes. That would be 1 kilobyte. But here I'm on a Mac, and one unit is 512 bytes. So we need to divide it by 2 to get the actual file size. So the actual file size would be about 168 kilobytes. What happens if I run exactly the same code on a Linux machine? Here we are on an Ubuntu. I put this somewhere so I can access it easily from my Ubuntu machine. And as you can see here, DU, I just provide an absolute path to my file. This is allowed as well. And we can see here Ubuntu tells us the size in kilobytes, which is pretty much what we would usually expect from a disk usage command. It's pretty weird that Mac does it in a different way. Well, is it? There's the so-called POSIX standards, which is a standard that defines how a Unix system should act. And Mac OS follows this standard, and within that standard, the block size is 512 bytes. So actually, Mac is just following the standard for Unix, which has been defined, and thus we get this result here. However, I also do agree that what Ubuntu is displaying or printing actually makes more sense for me. To change this, we could add a parameter, for example, -h, to get the size in a more human-readable format, and then also Mac prints it in a proper way. For example, here K stands for kilobytes. If the file size would be bigger, at some point there would be an M, which would stand for megabytes here. Or we could force Mac to use the normal kilobyte block size, and then it would also work properly. That would be this option here. Just be aware that by default, the disk usage on a Mac uses a different block size of just 512 bytes. So this output actually, it's quite confusing, but we can't change it. It's just how it is. So you now know how you can output the size of a file and how you can use the WC command to count the lines or also the number of words in a file. A quick interruption. If you want to learn more, this video here, it's just an excerpt of a 70+ hour long course about Linux. In this course, you will learn way more about Bash command line. For example, we will configure your terminal, or we will have a look at how colors work and everything like that. But you will also learn everything you need to know about Linux and how you can write Bash scripts, for example, a backup script. This course is super extensive because I decided to add so many different topics into this, so this is really the complete guide if you want to master Linux. In this course, you will also get quizzes, exercises, and a question and answer area. This is something that I cannot provide to you in this YouTube video here, unfortunately. So if you're interested, be sure to scroll down. I have provided a link for you there. However, let's now continue here with this video, and let's now get you started with using the terminal. In this lecture, I want to show you how you can edit files. Editing files directly with like a nice text editor is not possible in Bash. There's no built-in text editor for Bash. However, we can install additional software to also edit text files on the command line. Four quite popular options are Pico or Nano. That's a simple text editor for text files in Bash. Those are actually two different editors. We can imagine that Pico was the original editor and Nano is a complete rewrite with a few more features than Pico. The goal here for this editor is to have a simple text editor that's quite easy to use, in the sense that there's almost no learning curve for this editor. This is the logo of Nano. And then there's, for example, also V or Vim. Vim is also a complete rewrite of V, and it's been more extended with more features, and that's a more advanced text editor with a quite unique way to edit files, which may make you extremely efficient when editing files, though there's a steep learning curve involved. So you would need to learn this text editor before you are actually really fast with it. I'm fully aware that there are also more text editors, and I'm also aware that this discussion may be quite heated online, but please, let's leave this out of this course. Here in this course, we will just use Nano because it's a simpler learning curve, and I do not want to get into the details of how to be fast with Vim. Those text editors may already come pre-installed with our operating system. For example, on my Mac, Pico is installed by default, and if I want to start Nano, by default it will just start Pico. So some of those editors may already be installed on your system. If you want to install them afterwards, for example, you want to use the real Nano on a Mac, then you would just use the homebrew and then brew install Nano, or for example on a Ubuntu Linux or Windows subsystem for Linux with an Ubuntu inside, you could just install Nano with the usual apt-get update and apt-get install procedure. Let's now have a look how we can actually use this editor. Okay, so I'm here in a Bash, and let's say I just want to edit a text file. For example, I want to edit this text file. Then, if Nano is installed on my computer, which here in my case I've installed it with the brew command, otherwise it would just start Pico, but they act really, really similar. So I could just launch the program with nano space, and then I just say which file I would like to open. In my case, that would be the bash.txt file. I use tab to autocomplete the name of the file. If I open a file that doesn't exist, it would be created once I then save the file later from my editor. Now I hit enter, and now I can see that I have a basic text editor here, and I'm able to do some changes here. For example, instead of bash is cool, maybe I want to emphasize this a little bit more and add a few exclamation signs here. Then you can see that here below we have some commands that we can use. For example, if we want to write this file, I could hit this O key. However, this one here means that we need to press the Control key first. So I can just hit Control, keep it pressed, and then hit O, and then I can choose the file name, and I can just say, okay, this is the file that I want to save. Then I can hit Enter, and now this file has been saved. To then quit this editor, I could hit Control and X at the same time, and my editor has been closed again. To just open the file again, I could just use the arrow keys to get my last command and then hit enter, and now we are here back in our editor. There are also more things we could do. For example, we could navigate the file, or we could hit Control and C to get the current position in our file. Or you can see here, there are also a bit more commands, for example, for search or for cut and paste. Those do not share the clipboard from your user interface. They are a separate clipboard to cut and paste a line. But you can see we have some basic file operations here. It's not super advanced, but it's enough to get most of the job done. And I feel this editor is quite alright to do some small changes to some text files or some configuration files. Why would I use this if I could also use Visual Studio Code? Well, sometimes there's a little bit of overhead involved to use an advanced text editor such as Visual Studio Code. Imagine, for example, I would not be working on my own Mac here, but this would run on a remote server because I want to have a server to host some downloads or to host my website. So I'm a server admin, and then I connect to my server through SSH. We'll get more into that later, how we can connect to a remote server. But in that case, I already have a shell open, and I can just use a nano to change a configuration file on my server. If I would want to use Visual Studio Code, I would have to download this configuration file, open it with Visual Studio Code, then do my changes, then upload it again. Then I see, oh, I have a small typo in my configuration or something doesn't work. Oh, I need to do the whole process again and then upload it again manually to my server. So that would be quite tedious, and just having a small text editor that's running inside our terminal is extremely useful, especially when we're working with remote servers or if we do not have a GUI. For larger files, however, I do prefer to use a graphical GUI and a proper IDE or like an advanced text editor, such as, for example, Visual Studio Code. However, I also know people that actually prefer coding inside a bash-based text editor, but those people usually prefer Vim over Nano. However, Nano is the way to go if we want to have an easy way with a simple learning curve to edit text files in our terminal. In this chapter, I want to give you an overview about how streams work in Bash. In this chapter, you will learn how you can redirect the output of a program into a file. So far, every time we executed a command, it was shown directly in our terminal. After this chapter, you will be able to save this output and write it into a file. You will also learn how you can use a file as the input for another program, and you will learn how you can handle errors and selectively redirect only them, for example, into a file. This allows you to execute a command. It might generate output and also errors, and you can then be like, hey, I'm only interested in the errors. Or you could decide to do the opposite. You could also say, hey, I only want the errors to be, for example, discarded, and the rest I would just want to be printed on my screen. So this chapter will give you an overview about streams and how you can work with them. This chapter is important because it helps us to understand general Unix concept, though I want to note there will be later in this course another chapter where we'll dig even deeper into that topic, but that would be way too much theory for now. So in this chapter, we'll just have a look at how streams work in Bash and how input and output and errors are managed by them. And this is also important. Another reason would be that it enables you to build more complex commands in Bash that do more than just execute something. And it allows you to more confidently interact with the terminal because you really know how it works. In addition, though I kind of said it already, it allows you to save the output of a command to a file, and this can be extremely helpful when the output is long or really complex, or you just want to store it. So let's now get started, and let's now have a look at how streams work in Bash and how we can work with them. Let's now have a look at how we can write output to a file. Let's say we have a command that outputs something. It could be anything. And how do we get this output into a file? One way to do this would be that we just create our output, and then I could just try to highlight this, and then I could hit the copy key, and then I could create a text file, output.txt, and then use the paste function to paste it in, and then save it, and now we have the output in a file. This works. If I now cut this file, we see the output is in this file. However, this was a terminal feature. So this depends on my terminal, whether I can highlight something and whether I can hit the copy key or Command C to copy everything, or Control C depending on the operating system. This depends on my operating system, on my terminal, and it would also not work if there's a lot of output here. So at some point, this is no longer convenient, and it's definitely not the way to go to copy this and then just manually paste it into a file. Okay. So I delete my output.txt and let's start from scratch. Isn't there a better way? The question is, can we just, if we have, for example, a command such as the ls command, can we just redirect the output of this command directly into a file? Luckily, we can do this with the operator greater than. For example, I could use any command. In this case, this is an echo command, but it could also be an ls command. And then I could just use this operator, and then I specify a file name, and then this file is being created with the contents of the command that stands, or that's written there before. If the file doesn't exist, it will be created, and otherwise the file will be overwritten. Let's have a look at how this works. I could use any command. Here in my case, this is now just an echo. And for example, I could say here, well, let's stick to the common example, hello bash. And we want to use this output of this command. We see this is just a normal output. I want to use the output of this command. And I want to write this into a file. Then I could use this operator, and then I could say in which file this should be written. The file could just be like a file. It would be like a text file then. So the extension here, it doesn't really matter. But because it's a text file, I might as well just indicate this with a .txt at the end. If I now hit enter, we see there's no output here anymore, and all the output is now in this file. If I now output this file, we can see hello bash, that's the content of this file. If I now do another command and I write it into the same file, and now I output this file, we can see this is the output of my ls command, and the output has been redirected into a file. However, as we can see, every time we redirect output into this file, the file is completely being overwritten. So the old content of this file has been lost. Isn't there another way? Luckily, there is. We can also use the double greater than sign. And with this command, we can append to a file. So this means if the file doesn't exist, it will be created with the content. But if the file already exists, the content will just be appended. So let's just try it out. So for example, here, I just create a few dashes, and I use this operator now to append it to a file. So in my case, that would be the output.txt. If I now hit enter, and now I cut my output.txt, we can see that this line here has been created. If I would now, for example, add a few more characters to this file, for example, like this, I hit enter and now I output this again. We can see those show up now here in this file as well. As you can see, this one does not overwrite the file, but it just appends to the end. Let me give you another example. For example, I could also say, okay, give me the disk usage, for example, of my image file. And then we see, okay, this file has a file size of 2.8 megabytes here in this case. Let's say I want to use this and append this to our output.txt file. Then I could just use this operator here with a double greater than sign and just hit enter, and we see the output of this du command has been appended to this file, which we could see if, for example, I would access my output.txt either with a cut, or here in this case, I just want to get the end of the file, and we can see this has been written over here. However, is all the output being written into this file? Let's have another look. This one took the file size, and the output of this disk usage program has been appended to this file. However, let's say something happens that should not happen. For example, here, we try to access a file that doesn't exist. In this case, here, if I now hit enter, we see nothing has been written to my output.txt. Well, we don't see that yet, but we could see that if I cut the output.txt, nothing has been written into this file. However, the error is still being displayed here. So we see some of the output, or this operator works with some of the output. So some of the output, if everything works perfectly, all the output is being written to, or being appended to the output.txt file. But once a small error occurs, this error is no longer being appended to this file. Why is that? Why does the normal output end up in the file here, but the error output here does not end up in the file? And to understand this, we need to understand the output channels and how bash works. And then this will be, or we can understand why certain outputs ends up being appended to this file here, and certain other outputs is being displayed here, even though we are using this operator here. So let's get into the details in the next lecture so we can understand this behavior here. Let's now just have a look at why bash was acting in that way. In order to understand this, we need to look into the standard streams. And yeah, let's just have a look at that. So imagine we have a program. That could be any program. It could be our ls program. It could be a cat command. It could be anything. By default, there are 3 communication channels how this program could interact with the terminal. The one is the standard input. It is also called std_in. It means, or if the program wants to access our keyboard, then it could start listening to the standard input, and then this program could receive input from our keyboard. The next communication channel is the channel 1, or the standard output. This is called std_out, and this just means that our program wants to display something on our screen. So everything that our program outputs, it just sends it to the stream std_out, and then our terminal displays that in our terminal. There's another standard communication channel. If our program wants to output errors, there's also the standard error output. By default, this also gets printed to the screen, and this standard error output is called std_err. So, what does this greater than operator do? Well, by using greater than, or the double one, if we want to append something, we can redirect the std_out to a file. So, if we, for example, have any program here it's just an echo, and we want to redirect this, we can say, or we can tell the shell that the std_out should no longer be printed to our screen, but that the std_out should be sent to a file, and then depending on which one we used, it will be either overwrite the file or it will be appended to the file. Let's have a look at how this works. So, for example, I'm now using the du command. You will see that later instead of an echo. But for example, I could ask for the disk usage of a file, and I use the parameter -h so that we get it in a quite readable format here. So we see this is the size of this file. Everything has worked here. So this output is being sent to our std_out, and well, our terminal prints that one. If I now redirect this to a file, for example, here du.txt, we can see here this file exists, and this has been written in that or to that file. this du program, that's why we are using that one here to show it, we can pass in parameters that causes our du program to have an std out and an stdr as well. The way to go is, for example, if I would pass in a file that does not exist here, it will try to calculate for all the files that we pass in here, the file size. This one will work, this one will fail. So if I now hit enter, we see here both are being printed here in our terminal. This is because by default, our std out and our stdr both get printed in our terminal. So we see here, this file has a file size of 2.8 megabytes, and this one is the error message, and this has been sent to stdr, and it also gets printed in our terminal. If I now would redirect this output to our du.txt, I overwrite this file in this case, then I'm only redirecting the std out, the normal std out, to our du.txt file. So we see the normal std out has been redirected, but what the program du has sent to stdr still gets printed here in our terminal. We can also check here du.txt contains the normal output. However, the error, we have not redirected the stdr because this one by default only redirects our std out. The next question now, of course, is if we have a program that creates an stdr, is there any way we could also redirect that one? And luckily there is, and we'll get into that in the next lecture. In this lecture, we want to have a look at how we can handle errors or how we can redirect stdr. Why would we want to do this? Sometimes we want to redirect the standard error. The reason is that, for example, we may have a program that may print errors and we want to ignore them because they might not be relevant for us. So we would like to redirect the stdr, the error output, to nothing, that it just gets ignored. We will look into that in this lecture, actually, how we do this. Another reason would be that we are only interested in the errors and we want to redirect them into a file and to just save it and to have a look at them at a later date. So imagine we have a program that we want to run every day and it just prints out a lot of output. We want to ignore all of that output. However, the errors that occur, we are interested in them and we would like to look at them at a later date. So how do we do that? So far we have only redirected std out. This is a repetition of what we have been doing before. So imagine, for example, we have invoked a program here, or we have called a program here, and then we use this operator to redirect the output and to put the output into a file. However, this was the short version of this command. There's also a more verbose way to do exactly the same. And we could say here that we use the number 1 and we redirect the number 1 to output.txt. Why the number 1? Well, we had different standard streams. Stream 0 was std in, stream 1 was std out, and stream 2 was stdr. In this case, so far we have only looked into std out, which is stream 1. And this is the default stream for like an output redirection that we are using here. I could also explicitly tell that I want to redirect stream 1 into output.txt, though those two commands are equivalent. The second way I can use to redirect stdr. stdr is output stream number 2, or standard stream number 2, so I could just use the same command here, and with this, by writing this, I could redirect stream 2 into the file error.txt. Or I could also combine those. For example, here I redirect the default stream, which is std out, into the output.txt file, and the error stream I redirect into the error.txt file. Let's now have a look at this in our terminal. So here we are in our terminal, and what I'm using here now is the du command because I want to make sure that we have one command that creates an std out and an stdr, and du does this if we pass in one correct file name. It will print out the file size, and if we pass as a parameter one file that doesn't exist, then it will print out an stdr. So I'm just using this program that we have both here, like an std out and an stdr. So the way to go is that we could say here, for example, the normal output I want to put in, or I want this to be written into a file, for example, output.txt, and the stdr, I would like this to be written into the file called error.txt. If I now hit enter, we see there's no output being generated here on the terminal because the output has been redirected into one of those files. For example, if I print out the contents of output.txt, we can see this one here, and we can see that the error has ended up in the other file. This always overwrites our files because the one greater than signs overwrites the file, but we could also append it by using this by using the double greater than sign, and now it will be appended to our corresponding files. So for example, here we now have those two errors in the one file here. Another thing that we may have done here, but usually you wouldn't do this, but we could also specify that we want to redirect standard stream 1 to output.txt, so that we want to specify that we want to redirect the std out into the output.txt file. This is the default, and usually you just we would not write this down in this way, but this would be the more verbose way to write this command. There's also another way how we could use this. For example, imagine we have a program, such as this one, that sometimes creates some useful output that we would want to use maybe later in our shell script or in our shell, but we do not care about this output here. If we just enter the command here on the command line, we could say, okay, whatever, we can just ignore the second line and everything would be all right. However, sometimes there are ways in Bash that we could have an output here, and we want to parse this output with the next utility. We haven't looked into this yet, but it's possible to chain commands and combine them together and to create completely new use cases for them. And then if we would have an error output here, this could affect our whole script. So even though right now, if we just use a command here, it doesn't really matter whether it's generating an extra std error or not. Later it will matter, and we need to sometimes get rid of this error output so that our whole script can just continue running. So we need to find a way to ignore those errors. And the way to go is that we use our error stream and we redirect this into a special device. We can find it in the folder /dev, and the device name is null. This is just a null device, which means from a file system, from a program point of view, this is a file that we can open and write into it, and it will just be discarded by the operating system. So basically in this command here, we are using the error output, and we are writing this error output into a file /dev/null, and this just means that everything will be discarded. Let's have a look at this now. So I just hit enter, and we can see that the error output has been discarded. We could, by the way, also, if we wanted to, discard the std out by this, and then we only get the error output. This would then allow us to use this output as the input for the next step, and then do something with that one. More on that later, how we can combine those commands. So you see, we can just take the error and redirect it to, for example, this special file to ignore it. Or we could also say, okay, we want to ignore the normal output and we only care about the errors. Or we could do something completely different, for example, something like this or whatever, where the errors get discarded and the actual output gets redirected into a file. So we can really combine those two operators. Is there also a way to redirect the errors so they do not show up as errors anymore, in the sense that, okay, if a program creates an error, can we just take this error and put it on our std out so we can just work with it as a normal std out? And there is, and we are getting into that in the next lecture, and why we would want to do that in some cases. In this lecture, we will redirect std_err to std out. Why would we want to do this? The thing is, this allows us to easily store both outputs in the same file. So for example, if we invoke a program that outputs something to std_err and as well to std out, we might want to redirect both outputs to the same file. Right now, for example, if we want to start a program and we would like to redirect the std out and the std_err to the same file, we could do this, for example, here. And we redirect the std out and also the std_err into a file. We could do this. This would work actually. However, you can see we have to list the same file multiple times, and that's not really convenient. By the way, the double greater than sign means that we want to append something to a file, but also if we would just use the single greater than sign, then this would also work. It would not overwrite the file twice, it would only overwrite the file once, so both outputs would end up in the same file at least. So right now, we could achieve this if we want to have both outputs in the same file by just listing those two redirects here, and that would work. But you can see the file name, that's like a little bit inconvenient that we have to list it multiple times. However, we could argue, okay, this works and we can cover this use case, even though the syntax is a little bit expressive. However, there's one thing that we can only solve if we are able to redirect stdr to stdout. Later, I will show you how we can chain commands together. That will actually be the next chapter in this course, and you will learn about a new concept, the so-called pipes in Bash. And we can only pipe stdout into the next command, so once we learn how we can combine multiple commands to do something more, then it's really important that the output is all on stdout, at least the output that we want to pipe into the next command if we want to combine them together. So it's really important that we learn now how we can redirect stdr to stdout. So how can we do this? So if we have a command, we can just use this construct here to redirect to the current stdout. What the current exactly means, we will dig into that later in this lecture. So I can provide a command, and here I say the stdr should be redirected into the current stdout. Let's just have a look at the first command and how this works. So, for example, imagine here I'm in my bash, and let's say I have a command here that, for example, here the first image, this one exists, so this would be a normal stdout. And then, for example, this image here, this doesn't exist, so this would be printed to the stdr. We can now see both appear here in our terminal. However, this one is stdout, this one is stdr. The terminal doesn't show this exactly, but we know this, by the way, how the program du works. However, I could say, okay, let's take our stdr and redirect this, without this one, and redirect this into our stdout. So I could just hit enter now, and we can see it's still printing exactly the same. However, at this point, both are being printed through the stdout channel. This allows us the following construct. Let me go back to my slides. Here we can have a program. We can set, okay, we want to redirect the program into a text file, at least the output of this program. And then we can say, oh, and by the way, as well, we want to redirect the error also to our stdout file. So here in this case, we get all the output in one file, because here we redirect the stdout into that file. And here we say, okay, the stdr, we also want to be redirected into that file. Let's try that one out. So here I say, okay, this is my program. Then I say, okay, this I want to be redirected into a file, for example, out.txt. Here in this case, I don't want to append it. This one would be append. Here in this case, I want to overwrite this file if it exists. It doesn't exist as of now, but whatever, I want to overwrite this file if it would exist. And I want the stdout to be redirected into that file. And I also want the stdr to be redirected into that file. So right now, you see, nothing is being printed here on my command line because both are being redirected into the file. And if I now just output my text file, we can see stdr and stdout both are here in this file, and both have been redirected there. However, I want to emphasize a small difference because I feel like if we are here in my course, I really like to go into the details because I'm wondering about this stuff, and then I end up researching this for like a long time until I find something. I was wondering, imagine, or you see this command that we have here, and we see that first, this is the normal stdout, and then comes my error message that there's no such file or directory. However, here in this case, we have redirected both into the out.txt file. So technically, we expect that we have exactly the same output like before. However, if I output my file now, we see that the error message is being printed here, and only then we see the actual file size. So I was wondering, why do we have a different order here? Why do we get the contents here first, and then we get the error? And here we get the error first, and then we get the content. I was confused because I was expecting at first that both would behave exactly the same way. Well, it turns out that this is an implementation detail. It may be different on different computers. But it turns out that std_out is buffered, which means that if a program wants to write something to std_out, it's being buffered and it's waiting for a little bit more data until it's then actually being displayed or being written into a file. stdr is, at least on my system, it's not buffered. So whatever happens, it's being printed out immediately or it's being redirected immediately into the file. Now, the thing is, the std_out, so if something works, the std_out is buffered if we are in a terminal. It's line buffered. So this means, for example, here, if I take this command, this is running in a terminal and the output is being displayed in a terminal. So our program realizes, okay, this file has a file size of 2.8 megabytes. So it prints out this line, and it's line buffered, so whenever the line is complete, this line is being shown in our terminal. So this is how this line happens to be first. Then our disk usage program realizes, okay, this file doesn't exist, and it sends this to stdr, and on my system, stdr is completely unbuffered, so this one immediately shows up here in my terminal. Everything works, and everything is perfect. However, if we send the output into a file, because this is usually meant, or we can use this for large amounts of data, the buffering is changing here. Right now, because we are sending the std_out to a file, std_out is now no longer line buffered, but if the std_out of a program is being sent into a file, it's buffered, and in my case, it should be about 4 kilobytes of data. So it's buffering, it's waiting for this buffer to fill up until it's eventually written in those data. So our disk usage program here finds our first item. It's sent into the buffer because we are not writing every line into the file directly. We are waiting for more lines to arrive. So this is still in our buffer. The buffer isn't full yet. We are still waiting for maybe like 10 to 100 or 1,000 more lines that we could write all into our file all at once. Then our error occurs, and the error is completely unbuffered, so it's directly written into our out.txt file. And then our shell realizes, okay, this program is now completely, the program realizes, okay, I'm done now, so let's clear our buffer and actually write this data into our file. So if I now hit enter and we output this file, cut_out.txt, we can see here the error appears before, because this output has been held back because it was in a buffer waiting for more data to be outputted, but then no more data came, so it was written at this point. So the different order of the contents here in this file are actually a performance feature of my system, and it's nothing that we need to worry about. I want to go a little bit more into the detail of this command here. Why is this ordering here so important? And because this lecture is already quite long, we will dig into that in the next lecture, and I will tell you, or I will show you, why the order of those commands is extremely relevant here in this case. Why is the order so extremely important when we are trying to redirect std_err? So let's compare the following commands. For example, here, this is the first command. This is the one that we've used before successfully. Everything worked. But let's just change the order and see what's happening if we just change the order of our redirects. Let's have a look in our terminal. So this did work properly. Everything ended up in our out.txt file. We can open, or we can list this file, and we can see here our std_err is in this file, and also our std_out. However, I use the arrow keys up to get the last command, or the command before, and I just change the order here, and I'm like here 2 greater and 1. So I press enter, I call the file differently. I call this out2.txt. Now we can see our std_err has been printed here to our terminal. And if we open our file out2.txt, we can see only our std_out has been written to our out file. why has the std_err been written here to our terminal, and why is this text file only containing our normal output and not our error message as well? This is because the order of those redirects is extremely important. Let's have a look at our cases. So, this was our first case. In this case, we had our command, which may produce some std_err and some std_out. And the way it works, as a first step, std_out is redirected to our file out.txt. And then as a second step, std_err is redirected to the same destination as our current std_out when this is being parsed. So as of this point, the std_out points to the file out.txt. So also our std_err points to our file or to our out.txt file. So at the end, with this, if we use this command, both outputs redirects their content into the file out.txt. I've prepared a small visualization for you. So at the beginning, our command, both outputs go to our terminal. One std_out to our terminal and the other std_err also goes to our terminal. Then this is being parsed and our std_out is being changed to our file. And then when the full command is being parsed, then it's like this. It checks what's the destination of our std_out, and this will then also be the destination of our std_err. So if we are using this command, both will end up in our same or in the same file. Let's have a look at the other case. So this was our command, and in this case, at first, std_err is redirected to the same destination as our current std_out. So, meaning std_err is being redirected to the terminal, all errors will show up there. And then as a second step, std_out is being redirected to the file std_out, but this only affects the std_out of our program. So it doesn't affect the redirect that has happened here before. So only the std_out from our program will then be redirected to out.txt. So we can imagine it a little bit like this. We declare some mappings here that should happen, and then the command is being executed and those mappings are just being applied. It's not like it's first doing this and then doing this. That's not the way it works. We are just declaring those mappings in a specific order and then they're being executed. So if we want to visualize this, I've also prepared a visualization for this. So at the beginning, our command both prints std_out and std_err to our terminal. Then we say, okay, if we include this here, this creates a mapping. So the std_err now goes to our std_out terminal. So we have changed our std_err. And then if we parse the command completely, then we also get to this redirection here, and our std_out is being redirected to our file, but our std_err still points to the std_out in our terminal. So this is why we have seen the following behavior here. When we had this program here that creates an std_out and an std_err, and we use the wrong order here, then we see, okay, the std_err ends up in our terminal, and only the normal output ends up in our file. So when you use this way to redirect stuff or to redirect outputs in our terminal, then you need to make sure that this is always the last command or the last redirect that you apply here. Otherwise, it may not work as you would expect. We have now seen a lot about redirects. However, there was one more thing. Do you remember? There was also this standard communication stream with the number 0, std_in. And we can also use this for user input. And in order to show you that, I've prepared the next lecture for you where we will dig into the details for that one. A quick interruption. If you want to learn more, this video here, it's just an excerpt of a 70+ hour long course about Linux. In this course, you will learn way more about Bash command line. For example, we will configure your terminal, or we will have a look at how colors work and everything like that. But you will also learn everything you need to know about Linux and how you can write Bash scripts, for example, a backup script. This course is super extensive because I decided to add so many different topics into this, so this is really the complete guide if you want to master Linux. In this course, you will also get quizzes, exercises, and a question and answer area. This is something that I cannot provide to you in this YouTube video here, unfortunately. So if you're interested, be sure to scroll down. I have provided a link for you there. However, let's now continue here with this video and let's now get you started with using the terminal. At the beginning of this chapter, I told you that there are various standard streams how programs access our terminal. For example, number 0 was stdin for user input, number 1 was stdout for the output, and number 2 was stderr for our errors. We have seen a lot about the standard error and the standard out and how we can redirect those or how we can turn an stderr into an stdout. However, we haven't looked into stdin, and this will be extremely important also as a preparation for our next chapter where you will learn how to combine commands together. But for now, let's just have a look at stdin and let's lay the foundation that will be required for the rest of this course. How about stdin? The big question is, can we also redirect a file into the standard input of a program? Well, actually, so far, we have not used standard input at all. So first we need to find a program that also accepts user input. Let me give you one example. That would be the word count program, wc -l, for example, if we just want to get the number of lines. And let's see how in general user input works in our terminal. So I go here and I start the program word count -l. And in this case, instead of, for example, passing in a file name, I just leave this empty. This tells this word count program that we do not want to access a file name, but it tells this program that we want to access our standard input. Now I can hit enter, and as we can see, the command doesn't complete because it's waiting for me for some input. For example, here I could say this is bash, that would be my first line, another line, and so on. And then I hit Control and D to quit my standard input, and now we can see that this standard input, this has been sent to our word count program, and our word count says, okay, we are just interested in the number of lines. So it prints out this line here. So this has been our input. It just stays in our terminal because we have typed it in. It's not being outputted in any way. This is the standard input that has been sent to our program, and this is the standard output from our program. Actually, there's not just this one program that would accept the standard input. Also, the cat program accepts the standard input either by explicitly saying that we want to access standard input. This is just a minus sign that I enter there, or we'd leave it empty, and in that case, the cat program also accepts standard input. If we do not pass in a file name as a parameter here. Here, for example, I could say hello from bash, and then I hit enter, and this standard input, it was the same, by the way, with word count. Cat is just behaving a little bit differently. If I now hit enter, this standard input is being sent to our cat command, and cat immediately outputs this on our standard output. So this was our input. It's just being displayed because I've typed it in and stuff, and this is what cat then actually outputted. Or I could add another line here, send it to our cat program, and cat just outputs this one. It's a bit... I don't feel like this example is super exciting, but it shows that we do have programs that accept standard input and they do something with this input. To quit the standard input, I can just hit Control D and I'm back in my shell. Okay, so we have programs that can work with standard input. How can we send a standard input to a program? We can also use redirects, and we just use the smaller sign here. So for example, this is our word count program, and we can say the bash, okay, here we want to read this file, use this as a standard input, and send this standard input to our program here. So for example here, let's have a look. For example here, we have a text file here in this folder, still from earlier. This was one of the text files that we have worked with. And now I could invoke word count. For example here, I'm only interested in the number of lines. And I want our bash to read in the text file out.txt. Bash will read this, send this, use this as a standard input so that this stream is being fed by this file. And then it is being fed into our program as a standard input. And then we can see, okay, here, this is now our output. Of course, this would also work. For example, we could also tell cat, okay, hey, we want to read from standard input, or we leave it blank without a parameter, but I just use the more explicit way or the more verbose way here now to define that we want to read from standard input and not from a file. And then I can say, okay, please send the contents of this file into our cat command, and then I can hit enter, and then cat is sending this to our std out. Of course, I then could, for example, also redirect this std out to, for example, another file, let's say another.txt or whatever. So this means that this file is being read by our shell. It's provided as a standard input to our cat command. Cat is putting all the contents on our standard output, and we are redirecting the standard output to another file. Of course, by the way, copying the file in this case would have achieved the same effect, and it would be way more efficient and way faster. However, we can see that we are able to access standard input, and we are able to use those redirects here. Again, for now, it's not that important, but it will be super important in the next chapter. By the way, just so this is actually really complete, also the word count command, this is not really efficient because the bash now has to read this file, send it, put it on the standard input, and then the word count has to read the standard input and access the file through that one. But actually, word count, this program can also read a file directly, and we do not need the standard input here. So this command should actually be preferred if we are just interested for the number of lines in a file. However, you can see that we are able to use standard input with those programs. And again, in the next chapter, this will become the basis of chaining commands together. So we have now learned a lot about those standard streams and how they work, how we can use or how we can work with user input and with user output and with the standard errors, and how we can redirect those into files and into each other. So I feel like by now you pretty much know and you've mastered those standard streams and how they work on our Unix systems. In the next lecture, I've prepared a small quiz for you so you can test your knowledge. In this chapter, I want to teach you about pipes in Bash. But let's first have a look at why this is important for us. Let's start with a simple example. How do we count the number of files in a directory? Right now, this would be quite inefficient. We would have to use the ls command to list the files in our directory. Then we redirect this output into a file. Then we count the number of lines in this file, for example, with the word count program. And then, of course, we remove that file. However, this output.txt file should actually be in a different folder. Let's just have a look at an example, and it will be clear why we have to be aware of that. Let's just have a look. Okay, so here I'm in a folder, and as you can see, there are 3 files in this folder. Let's see how we can now use this. So I could now say I want to output the contents of this folder, and instead of outputting it in my terminal, I want to redirect this into a file, for example, output.txt. When I call ls in the terminal, ls detects where the contents or where the output is being printed to or given to. If it's being printed in a terminal, everything will be in one line. However, if we redirect the output, ls can detect that, and then everything will be in a new line. So if I now hit enter, we can see all the contents of this folder have been redirected, or all the files that are in this folder, the information about that from the ls command, the standard out, has been redirected into that file. However, if we now open that file, for example, and we read it, we can see there are files, and the output.txt file is also listed there. This is because this file is being created as a completely empty file at first, and only then the output of the ls command is being redirected into that file. So that's why I had the note on the slide that the output.txt file should be in a different folder, so it doesn't affect the actual contents of this file. However, here it isn't, so right now in our output.txt file there are the 3 original files and the 1 file that has just been created before the ls command has been executed, so that's why we have 4 files here. However, I can now still use the word count command, for example, to count the number of lines that we have in that file, And as you can see here, we have 4 lines in this file. So we know right now there are 4 files in that folder or in our current folder. We have to subtract 1 because of our output.txt file, so there are 3 files in that folder. Now I could just remove my file or this temporary file and everything would work. This was extremely tedious and it's definitely not a nice way to calculate the number of files in a folder. So isn't there a more efficient way to achieve the same result? And luckily there is. And in this chapter, we will get into the pipes in Bash, and those will allow you to combine multiple programs together. And this, for example, will solve exactly this problem, and we will just need literally just 1 line of code in our Bash to calculate the number of files, and we will no longer need a temporary file. Also, this will then allow us to use some programs to perform basic string manipulation, for example, like a replace on a string, but we'll all have a look at that in this chapter. Let's now have a look at how we can solve this problem by using a pipe. So let's look, what is a pipe? The pipe is a mechanism that passes the output of one command as the input to another command. Thus, we are able to chain multiple commands together and build more complex functionalities, and it's still extremely compact. The general syntax is that we just use the first command, then we use the pipe character, and then we just list the next command and so on until we are ready. We can imagine that a little bit like this. We have a command that outputs something on stdout, and the pipe character then takes this output and uses it as the input to our next command. And then at the end, if this is the last command in our pipe, then the result will eventually be displayed. Let's have a look at how this works. So let's say I'm again in this folder and I use the ls command to list the files in that directory. Now I can use the pipe character to use the output of this command as the input of the command here, as the standard input. What could I do with this? Well, for example, I could use the word count command to calculate the number of lines. And in this case, if I do not pass any parameter to my WC program, then the WC program will read from the standard input. So in this case, the ls will print out the files to my standard output. The pipe makes sure that this standard output gets redirected to the standard input of this program, and then the result of this one will be printed. So if I now hit enter, we can see that there are exactly 3 files in this folder. Again, here, if we use ls and the output is not being displayed directly in our terminal, but we use it for either a redirect, that was the chapter before, or within a pipe here, then all the files will be in a separate line. So we can just count the number of lines, and this will then at the end count the number of files. We can also see this, for example, if I pipe this into my cat program. If I do not pass a parameter to cat, then it will read from standard input, and the standard input is now the standard output of my ls command. And now if I hit enter, we can see that in this case, if ls is being used in a pipe, it will list the files in a separate line. Let's have another look how we can combine all of that. For example, imagine I want to get the disk usage of a few files. For example, I would imagine I would have one file here and another file here. If I now hit enter, we can see this is our standard output, the disk usage of my one file. It's an empty text file, so it's 0 bytes. However, the other file, that one doesn't exist. Now let's imagine we want to just check whether there's any errors or whether any errors have occurred. Then we could say, okay, let's redirect the normal output, the standard output, to def null. I hit enter and we can see only the standard error is left here. And then I could say, okay, let's redirect the standard error to my standard output. And if I now hit enter, we can see, oh, both have been redirected. This is not what I want. I need to do this redirection before, because otherwise the order here is really important. Here I need to redirect this before, so it actually gets displayed on my standard output, and then the normal standard output I redirect to def null. So this is the order that I need here. So in this case, we can see this program now only output, or this command now only outputs standard out, this one here. So we can use this in a pipe now. For example, I could now pipe this to my word count program to count the number of lines. And now we would see that there was one file that did not exist, or one file that has caused an error here, or one parameter where the file did not exist. As you can see, the syntax here becomes really compact. And I have to admit, at the beginning, it may look a little bit like, oh my God, there's so much happening here. However, if we really go through, this just redirects the error to the standard output. This redirects the standard output of our program to null. And then we just count the number of lines. Then we can actually understand this command and how this works. And this is kind of the magic of Bash and the magic of the shell, that we are able to express a lot of stuff within just like a few letters or just one line of code. And in other programming language, if I would imagine, I would have to write a Python program for that. I don't know, maybe 5, maybe 10, maybe 15 lines of code just for the logic that I've expressed here in this one simple line. So as you can see, there's the downside that the syntax is really, really compact, but there's also a really big upside that we are able to do a lot with just like a few, or with just this one short command over here. You might have seen that there are always a few commands that we see all over the place or over and over again. For example, the word count with a parameter -l to count the number of lines. There are more of those programs, and they make a lot of sense when we are using pipes. So in the next few lectures, I want to take some time where, well, we have understood pipes now already, but where I will introduce you to really common programs that you can use with those pipes, because this will allow you to actually use those pipes in production or in your shell commands. So let's have a look at those in the next few lectures. Let's now have a look at a commonly used tool, the tool T. What does the tool T do? With the combination of a pipe and the T command, we can create a standard output and write it to a file at the same time. So far, we could either redirect the output into a file, or we could have the output displayed on our command line. With the command T, we can do both. So, for example, the command echo hello world, we want this to be redirected into a file, and we also want to see this in our shell. Then we can use the T command to write it into a file, and then also print it to std out. If we want to append, we could use the parameter -a, and it will append to that file. We can imagine the T a little bit like an actual T. So imagine we have our command here. In our case right now, this is an echo, but it could also be an ls or anything else that produces an std out. And then the T command redirects this output into a file and into our normal std out, which means it's still then being printed in our terminal. Let's have a look at this, at how this works. So, for example, imagine we have an echo, for example, hello world. This is exactly the same example that we had before. And then I could just pipe this output into our T program. For example, I could write then this into my file hello.txt. We can see here an std out has been created, but it has not been displayed in the terminal because there's a pipe behind. So the std out gets collected and it gets sent into our T program as an std in. The T program then sends this output or writes this output into our file hello.txt, and it also writes it to std out of our T command, which then at the end shows up over here. We can see hello world is being displayed here. However, we also now have a file called hello.txt with the corresponding content. Why did I explain it so complicated that this echo doesn't output it immediately? Well, the thing is, we could add another pipe over here. For example, we could count, let's say, the number of characters, WC space -c. What's happening now? So here we have an std out that's being created, hello world. This is being sent into our T program. Then the T program writes this into a file. So hello world, exclamation sign, it's being written into our file. And hello world, like this sentence, it's also being sent as being outputted to std out from T hello world. But because there's a pipe behind, this std out is not being printed in our terminal, but it's being redirected, or it's being sent as an std in to our word count program, and we only get the number of bytes over here. To get the number of characters, we would have had to use -m as an option. However, if we cut our hello.txt file, we see that there we get the full version and not just the number of characters. So we can see how we can just store stuff here and then work with it later. You can imagine if we have a complex pipe with like multiple steps behind each other, then the T command can be really useful because we can just write stuff down or write the output down while we develop the rest of our pipe to combine those elements even further. And we can use it that if something, for example, breaks or it doesn't work anymore, we still have the output from before and we can work with that one. I want to show you another example. There's the ping program that allows us to send a ping packet to another server, for example, a remote server, and this we can use to test whether this server is reachable or whether our internet connection is disrupted on the way to the other host. So for example, I could say ping google.com and it would send a ping packet to google.com and it would send that one. And then Google would reply to me and I would see here how long this takes. So I can measure my ping to a remote server. By the way, to cancel this ping procedure, we can just hit Control and C and then the program here is canceled. However, if I want to ping a host that's not reachable, let's say Google and then hands-on-keyboard-whatever.com. If I now hit enter, we can see that this is an error message. As for most bash programs, or command line programs, this error message is being sent on std_err. How can we see that? Well, I could, for example, redirect the the standard out to def null, and then we can see the error message is still being shown. So this is an error message that's not on the std out, but on std_err. So what I can do is, for example, that I can say, okay, wait, I clear my screen first. So for example, what I could do first is that I want to take my std out and redirect the std. I don't want to take my std_err and redirect this to my std out. And then I could pipe this into my T program and write everything down, ping.txt. Now, of course, I should try to ping a host that's actually in existence, so maybe just google.com instead of the other one. And now, if I can reach google.com, this ping program will execute and all the output will be sent to the T and it will be written down in a ping.txt file. However, if an error occurs, for example, because my Wi-Fi connection has dropped or my internet connection has dropped, this error will be redirected to std out, and then the T will it will be the std out here of this one because it's being redirected here, and then because of this pipe, the error arrives as an std in for my T program here, and it's being also written into my text file. So if I now hit enter, I can see the ping is working. I can leave it running for a few times and then cancel this program with Control and C again. This now allows me that I can watch whether my internet connection works. However, if my internet connection fails, I have it documented here. For example, that maybe here I didn't get a reply from my remote host, or maybe I got another error or whatever. That's all the errors end up at std out and also are written into my ping.txt file. So if any errors occur, I can just go to my internet service provider and send them this file, and I can be like, hey, this was the output of my ping program when my internet connection failed. Please try your best to fix it. Stuff like this is also a usual use case for our T program, where we have any program that creates output either just on std out or also on std_err. And then we redirect this to std out and we just save it and display it at the same time, but we save it for later use or for documentation purposes, so we have some proof what actually has happened. Yeah, this was our T program, which is a really useful utility. In this lecture, I want to introduce you to two more common tools. The one tool is sort, the other tool is unique. Let's have a look at them. This program sorts the contents in a file or stdin. By default, in alphabetical order, so it sorts this data, and by default it prints it to std out. So by default it doesn't, if we invoke or if we pass a file name as a parameter, by default it doesn't change the original file, but it just prints it to std out. By default it sorts it in alphabetical order. However, we can sort it also in reverse order, or we could sort numbers to the numerical order. This helps if the line, for example, starts with a number, that then the numerical order is being maintained. Then we should use the -n parameter, or we can just check whether a file is already sorted using -c. Or we can use also the -k parameter and specify a column number, and then the data will be sorted by a specific column. Let's just switch to our terminal and have a look at how this works. Let's assume we have a file, for example, file users.txt with students that want to learn Bash. If I cut this file, we can see those were the students that, let's say, they've signed up for a seminar. How can we sort them so that later we can just print this list and we can find those students? The way to go is that we just call the sort program and we just pass in a file name, and then sort will open that file name for us and the list will be sorted. And we can see that there are quite a few duplicates. How we can remove them, we will get to that later. Another way to use sort would be that we first cut our file so that it's outputted to std out, and then we run it on stdin by not passing in a file name. This, of course, we can use, especially if this would be another program. However, if we just want to read in a file, of course, this one would be a little bit more efficient because we do not have those two commands that we combine together. Everything is in one command. However, if we do have an output that we want to use as stdin to our sort, this one works as well. Let's have a look at the other parameters. There was another one, -r, if we want to flip the order. So we see here, it's now sorted in a different direction. And the other one was -k. What was that one? Let me go back, -k. And for example, I could sort my data based on my second column. If I now hit enter, we see that my data has now been sorted by my second column. So in this case here, it has been sorted by the last name, and not by the first name anymore. You can imagine if you want to achieve an alphabetical order or an order in any other way, this sort command can be extremely useful because it allows you to sort this data. There's another command that I want to introduce you to, and that's the unique command. The usual way that you see all over the internet is that we first sort our data. However, we do that whether we cut it first and then we pipe it into sort, or we open the file directly. And then once the file is sorted, we call the unique program, and then we only get the unique lines. So if we have if we have duplicates here in our data or like repeated entries, those all will be removed. Let's just see how this works. So here I could first sort my data and then I pipe this into the unique program, and then we can see the duplicate entries have been removed. Let's have a look why we need to sort the data first. This is because if we don't sort the data and then pass this as a standard input to our unique program, then we see that the duplicates have not been removed. This is because this program only removes duplicate lines that are just below each other. So if, for example, Ella Woods is here and then there's some other data in between and then Ella Woods is here again, she will not be removed as a duplicate because unique will have forgotten about that one. So this is why we need to sort our data first and then we pipe it into the unique command. This is what you find all over the place and as a good combination for pipes. However, there's also a shorter way that's a little bit less common, but the sort program can do everything at once. So we can just call the sort program with another flag, the -u flag, and it will do exactly the same. So for example, here, users.txt, and it removes the duplicates, or I could also cut it and then pipe it into the program and it would work exactly the same. So this would usually be preferred. However, the first way to write it would also work. Another thing we quite often want to do is that we don't just want to remove duplicates lane, but we want to actually just find the duplicate lanes in a file. And this is what we can do with a combination. We can say we need to sort our data first, and then we pipe this into unique with the parameter -d, and then we get a list of all the duplicate lines. Let's just have a look. For example, here, I just use an extra pipe here, sort my data, and then I pass it to unique -d, and we can see those were the duplicate entries. Of course, a little bit more efficient would have been if I would have written it like this, but then I couldn't have used multiple pipes. And in this chapter, we are here to practice pipes. So, of course, this one has a few more pipes or one more pipe in it. So, of course, I need to use that one as well. As you can see, we are now able to list the duplicate entries, and you can imagine this might also be quite useful from time to time. So this was already great. You can now confidently start using the terminal, and you can now continue exploring the terminal. However, if you do want to learn more, this is just a part of a 70+ hour-long course about Linux. In this complete course, you will learn not just about Bash command line and more advanced use cases for that. You will also learn a lot about Linux, how you can manage the software there, how the networking stack works, but even explore advanced concepts such as firewall-D or SE Linux. Also, we will have a more in-depth look at Bash, and we will explore how you can write Bash scripts and really write, for example, your own backup script. This is a 70+ hour-long course because it's just so extensive and I wanted to cover so many different topics. So the course got longer and longer, but you can benefit from that. It's everything built on top of each other. It's everything that you need in just one single course. So if you're interested in that, be sure to scroll down a little bit, and I've provided a link there for you so you can look, or you can have a look at the complete course. Aside from that, thank you for watching this video, and maybe we'll see each other in another one.